Eutelsat Group, the Vice President, Mr. Daniel Corbett, is present amongst us today, and we are having the discussion over what the company is offering to students and how they can strengthen the work and how you can align your work with the directions and the mission and vision of the space science communication area. So we request you to kindly, if you have the internet access at the here, you can go to the company profile, listen to the deliberation very carefully because he's going to explain about the company, what they are offering, what are their vision and mission, and how you can align the work, and ask as many questions as you can because they are looking forward that how they can engage our students with the company, right? So it's a humble request to each one of you that listen to the deliberation very carefully, ask the questions. If you have any doubts, you can clarify your doubts with from them, and just have the 100% outcome oriented discussion this time. So take benefit out of this visit of the international delegation. Thank you so much.
हैवी है ट्रांसफर नहीं होगा कनेक्ट हो जाएगा तो उससे पहले आपको कराओ क्योंकि वो शेयर नहीं होगी अदरवाइज हाँ कहीं हाँ इसके साथ क्या आ जाओ ये अभी स्टार्ट आ जाओ आप आ जाओ आप हेलो हाँ और शिफाली क्या ना वो कनेक्ट हो जाएगा बच्चे को पहनाने और बिठा उसको पास शुरू copying all ट्रांसपेरेंसी जो चीज में हमको डायरेक्ट मेल आ रही है उसको ना सिर्फ डायरेक्ट मेल ही आ गए तो पहले चाहिए तो मैं बता दूँ स्टार्ट है ना सर जाएंगे तो मजा आ रहा है पर काम भी काम करते हैं बड़ी खुशी होती है काम करते आपको बच्चे को अपने बच्चे मेरा बच्चा तो इनमें से एक जैसा लगेगा वो थोड़ी देर पर तो उस कोने वाली सीट पे बैठेगा मॉर्निंग से आगे आशीष भाई सर को बुलाते हैं आगे ले your tell sound. Good morning to all. Good morning. आप साथ में
Good Good morning. Good morning, all. Can we have a big round of applause for our guest this morning, please? Thank you very much. So, today we have our guest with us, Mr. Daniel Crowboth, Vice President of Satellite Operations, Eutelsat Group, Ms. Nistha Kapoor, Regional Director India, SARC, Africa, Eutelsat One Web, and Group Captain T.H. Anand Raoji. And on behalf of our Honorable Founder President, sir, our Chancellor, sir, Vice Chancellor, Madam, and on behalf of all the Amity Group, Amity family, would like to welcome you this morning to our guest. And we are thank you very much for sparing your valuable time. The Eutelsat, to tell about Eutelsat is a global leader in satellite communication and which is delivering the secure and high performance connectivity across the world. And it is the world's first fully integrated multi-orbit satellite operation, combining with fleet of 31 geostationary satellites with a low Earth orbit and installation of over 600 satellites with over 4 decades of experience. Its presence is more than 50 countries now. And the evolution was again start from this company was this organization started in 1977, and with the creation of Eutelsat international organization, then it has never looked back. After its inception in 1983, the first satellite was launched, and that was the this type of a new initiative, and which make the D2H easy for worldwide direct to home signal that has made. Uh, in 1995, they have launched the Hotbird 1, and 2000, the first consumer internet service provider are the Eutelsat they had done. So in 2021, they have transformed into a private company. Never looked back after that. 2005, that goes public in listening France Stock Exchange, and 9 satellite carries the first on-board multiplexing capability. Now, since that time, it was the analog-based signal that you are working on. So in 2009, the multiplexing was done, which was enabled the digital transfer also of the data as well as possible. So 2010, then 2012, OneWeb was founded, and that was the idea of providing low frequency, low latency alternations. So that was in, and 2014, they had done the first Ultra SD demo channel, and that again SD direct to connect, which was enabled by the company. So then 2019, the OneWeb launches first 6 LEO satellites, and that was launched with the joint venture of OneWeb and Airbus. So this was the journey in 2020, 25, and 26 now, and this was a great organization. And just for the information of our guests, Amity Group of Institutions has established 12 campuses across the country, 17 campuses outside India, imparting the quality education to 250,000 students at a time, including the schools, preschools, institution of higher education, and more. We have an alumni base of 700,000 students, alumni across the world. So it's this event will also serve as a amalgamation of two great institutions, and will definitely produce the great outcome when we meet together and when we are discussing about how we can collaborate and how Eutelsat and Amity can bring the best outcome for the student and the organization. So with this, I would like to welcome all the guests this morning once again. Thank you very much. So now I'll request Dr. W. Sulamurthy sir for just put forward his words about the Amity group, our research innovation, and all the best practices that we are offering to our students and across. Thank you, sir.
So very good morning to all of you. So my dear students, today you are going to interact with a very distinguished leader in space science and technology who has been introduced, Dr. Daniel Krobat. You might have seen the Wikipedia profile, a man amazing personality who has really put a signature at the global level at the top of the space. And then a man who transformed an organization which was small into exponential growth, that is Dr. Daniel. So let's welcome our distinguished guest with a big clap as an applause. Our Honorable Founder President, Dr. Ashok Chauhanji, who has created this whole Amity universe, which he mentioned, with 12 independent universities in India, 18 campuses, global campuses across in different countries like Dubai, Mauritius, Singapore, London, Romania, USA. We have 2 campuses in US. And we also are in Tashkent, and we are in Abu Dhabi, Amsterdam. So we have a big global presence. As he was mentioning, a little correction that we have 800,000 alumni and 250,000 students, 10,000 faculties, 5,000 PhD scholars. So it's a great university, great universe, Amity universe, built, founded, and steered by our founder president, Dr. Ashok K. Chauhan. Above everything, he has announced a very big mission, Amity Space Mission.
Announcement from founder sir. So just before sir will start, because Honorable Founder President sir wanted that this program is putting on the Amity YouTube channel for reference of all of us, even in the later course also, in now also, and so that all the Amity universities in India, abroad, is watching it. And thank you very much, sir, Founder sir. Thank you very much.
So founder president has been watching this program, and he has actually architectured this whole program, how we should structure the interaction with students, and also how we present Amity space mission to the visiting delegation, and also what do we do with them. So this is what he has guided, and the whole program has been steered by founder president. Welcome, founder president, and thank you so much for inspiring, motivating all of us to give a new impetus to this Amity space mission, aligning with not only Indian space mission, but the global space mission. And that is how this Daniel Krobat's visit is very important. And founder president, chancellor, Dr. Atul Chauhan, we have attached great importance to your visit. And we would like to do many things together in terms of capacity building, students' progression, internship, also the placement in your organization. You have a big growing company. And I was just talking to him very briefly. What are his thoughts in terms of looking at his own mission in this organization, which is known as Eutelsat? He said that the communication, space communication, and how do we build more satellite? And when you have this satellite position, how do you predict whether this satellite will last so long so that you can plan a redundancy in other systems, or you can replace that satellite? And then we can also remove the payload and then reuse, recirculate. And one mission is 5G in space. So this is what he said, the communication, very important. So why I am telling the students, he is looking for a great opportunity for all of you to contribute to their mission. And through Amity Space Mission, we will contribute to Eutelsat, which is a 1977 established. Almost next year, they will be celebrating 50 years, Golden Jubilee. So that is the organization which is competing with SpaceX. and also Starlink. That's the number one. So this is the company, and this is a group of companies. Actually, they have a group, so which is competing. So here is the vice president of that organization who is here today. So let's welcome once again Mr. Daniel Krobach. Then we are also fortunate to have Ms. Nishta Kapoor, and who is also coming to Amity. She has done a lot of the business experience, marketing, and she is the regional director, OneWeb regional director for SARC as well as African countries. The Burlington English India, she was the head of the marketing and branding. Airtel, she spent a lot of time, more than 8 years in Airtel. Business analyst to CEO of Gujarat. This again for the space and other missions. Uninor, that is another big company in which he was the marketing manager. So you have such distinguished people on the dais, and thank you, Nishta, for being with us. And we want to work with you as with your organization. I want to introduce our group captain Anant Rao. Anant Rao, he is the one who brought this delegation to us. So can you just get up and present yourself? Let's give a big clap to group captain T.H. Anand Rao. She is the director of ISPA, that Indian Space Association, which the government established two organizations to spread the capacity across the country instead of only ISRO, Indian Space Research Organization being the central point. We wanted to build the national capability and capacity. So the government of India, under the able leadership of Prime Minister Shri Narendra Modi ji, they pronounced a very big policy, the space policy, where we wanted to build the national capability. So industries, academia, how do we bring them together? So ISPA was the genesis, and also InSpace. These two organizations, Government of India established to build this national capability both in academia and industry and working together. So that is where this organization, Eutelsat, was a founding member of this ISPA. So that again is a big credit to this organization, Utel, because to create this structure, to create the vibrance, and that is how they are connecting with us here. Anant Rao, who has flown different aircrafts. He has flown MiG, and he has flown Jaguar. So all these fighter aircrafts, he has been in the cockpit, he has been flying. So we have the fighter pilot, then he served in the air headquarters, then he served in the air command headquarters. So such a great person is here. Thank you so much, Anant Rao, and Amity is a very strong partner with ISPA. Now, we make all the proceedings of the conference, and we are an academic, very starred and favored academic partner with ISPA. So, founder, president, and all of us are very keen to expand, deepen our relationship with you, because you have always Amity in your heart, not just in your mind. That is how you thought of bringing such a great delegation over here. So, once again, welcome all of you, and thank you, Manoj Kumar Pandey, for organizing this interaction with the students. Students, you have to be attentive in what all these distinguished speakers are going to speak and interact with them. Know more about it. How do you connect with them? How do you become a part of such great mission and great successful leaders? Start dreaming like this. That is why we bring you here. So I want your active participation, interaction with the delegation. And I must also thank our Prasad, MS Prasad, who is the director of Amity Institute of Space Science and Technology, and who has spent a lot of time in DRDO. He served there for 35 years in DRDO in critical strategic missions and the programs. And he is here as the director of the Amity Institute of Space Science and Technology, Shivani. And we also have our Ashish Mani. So many people are here. So they're all here to interact with you. And Shefali Kashyap, just can you stand up? She is the one who drives from the headquarters, our Amity headquarters, the AFSIA, Amity Foundation for Space Science, Technology and Innovation Alliances, and the space mission of founder president is driven by Dr. Shefali Kashyap. Let's clap for Shefali and Isha, all those Kamakshi, everyone who is associated with this. So we are all eagerly looking forward to hear you, and also we would like to see what all we can do with you. With this, once again, welcome to the distinguished delegation. Thank you, Founder President, for coordinating this.
Thank you, sir. Thank you for your words of wisdom. Now, it's my privilege to invite Mr. Daniel Klobot to say a few words to our students. Those right now sitting is from the communication, electronics, remote sensing, because remote sensing is also important, GIS and all details. To say a few words about Mr. Daniel. He completed his Bachelor of Science in Computer Engineering from Georgia Tech University, Technology, and joined the software engineer in 1999. And then he has served in many profiles in many of the companies in system engineering associate, system engineering manager, Millennium Space System INC, where he had worked in senior flight development engineer, and in October 8 to March 2012. Then fleet management system in August 15 to January 16, and then when OneWeb is where he has really started his journey in the Eutelsat and senior principal system engineer for 8 years, and now the vice president and LEO of satellite operations from May 24 to March 25, and then vice president of satellite operations from March 25 till now. So thank you very much, and you have the big, great experience of 2.5 decade experience that we would like to know, learn from the experience our students want to know about what all the innovations, experiences, and innovations that your company is doing in terms of the space and satellite. Thank you very much, please.
Thank you very much for the very kind welcome, very kind introduction. I really appreciate the invitation to come speak here today, and especially to interact with you, the students. You may have heard from my introduction that I'm not an aerospace engineer, not originally. I don't even think I'm one now. It's computer engineering, and then I got involved in satellites through the course of my work. And what I found in that experience is that in aerospace engineering, particularly in this new area of LEO constellations, what matters is new, fresh ideas. And young people bring those new, fresh ideas. And so that's why I'm very excited to be here and speaking with all of you. When I look at my team, because I have several teams, I have GEO satellites that I fly out of Paris and Mexico City, and then I have my LEO team in London, in the United States. In London and in the United States, I hire people right out of school because we're flying a LEO constellation. There's really only 2 LEO constellations in the world that are of our scale. There's Starlink, which has 10,000 or so satellites. We're an order of magnitude less, we're 600 satellites, but still, that's a very different way of operating, a very different way of working than when you're flying just a few handful of satellites. You have to come up with new ways of addressing problems. You can't just you can't test everything. There's 660, in our case, random number generators in space that are always doing something crazy, always doing something weird. And if you think about it in kind of the old mindset of you must test everything, you must make sure everything works before you do anything new, you'll never make any progress. And so when you bring new people in, and new students who have just graduated, and you expose them to the ideas and you ask them, how can we need to be closer. How can we solve the problems that we're facing today? People who have just finished their education, who have wide open minds, who have the ability to solve problems and engage, are the people that we're looking for. They're the people who bring the answers in this new paradigm of satellite operation. So that's why it's very exciting to be here in India, to see the progress that's being made in this country, and to see where there might be opportunities to collaborate. So that's very exciting. I think, you mentioned a little bit around some of the challenges that we have, some of the interesting areas that we have to work on. And, for me, really, the the new frontier is how can we be as efficient as possible with what we have? When we launch satellites, they have a lifespan, they have design parameters, but there's always a question of there's what the requirements say, and then as good engineers, we always add a bit of margin, right? So the question is, how do we exploit that margin once we get the satellites in space? How do we keep them working longer than we had originally asked for? How do we expand the mission beyond what we had originally thought of? What capabilities are inherent in some of the, for example, the AOCS sensors that are on board, the star cameras, the GPS, the GNS system? Is there something that we can do with those bits? And so that's what we like to have young people think about for us. What can we do? What some of the bright ideas that we have in the area of AI? That's something that we think has great potential because we have 600 satellites. They're divided across 12 different planes. So think giant circles in the sky with 50 different dots on them spread across the globe. Many of these satellites are doing exactly the same thing. They're all the same design. So we expect them to age in the same way. We expect them to fail in the same way. But it's always a little bit random. And so there's a lot of data out there. And what we're looking for in a lot of cases is ideas of how we can sift through that data, how we can sort through that data, how we can detect problems before they happen. Because unfortunately, it's not like driving where you can just change the lane really quickly. Everything takes time. It takes time to reposition satellites. So it takes maybe 3 weeks to move a satellite from one spot in the ring to another spot in the ring. So if we can come up with ways where we can detect problems 3 weeks before they happen, 4 weeks before they happen, that's a great advantage for us because then we can pre-position something. Our customers don't complain when a satellite has a problem and has to go out of service. They don't yell at Nishda and wonder why are we not getting service. So things like that would make her life a lot easier. So there we go. So that's a little bit about me. That's a little bit about what we're doing. But I'd really love to hear from you. What are your questions? What are you curious about? And yeah.
Thank you. Thank you, Mr. Daniel, for putting your words regarding the issues that comes to maintaining the satellite, especially because every satellite have a specific time span where it is working, and how to keep that working for longer is definitely being a great challenge for every scientist in the world. And as you know that there are so many satellites across maybe 600 satellites that are working on across the, and extracting the information from all is again very important. All the student of the communication and the remote sensing, how many remote sensing student? They can understand when the GIS data, or have you heard about LIDAR data? When you are talking about LIDAR, when actually you are making the maps of the place, and based on the LIDAR data, when you are making any decision about the deforestation or any other other decision on that matter, so it become really difficult for that. And yes, of course, please do the servicing of the satellite regularly. That will be my suggestion to you. Servicing of the satellite also is very, again, as you said, your customers are telling you again and again. So that again is a great, because every customer does not understand how it is difficult to maintain the satellite once it is in the orbit. So, but yes, thank you very much for putting your words forward. We have with us Ms. Nishta Kapoor, who hails from the India and started after pursuing her MS degree from B.Tech degree from MS University, Barodara. So she joined the many profiles across the country when starting from B2C marketing manager in Gujarat. Then in Airtel, she started strategy lead for CEO global businesses in Airtel. And then Burlington English India, head of marketing and brand, and OneWeb. That is the organization right now working in. She is the regional director of India and SAARC Africa. So thank you, Nishta. So would like to just say a few words about your challenges and your opportunities that you had faced in OneWeb and how the student can get benefit out of it. Please.
Good morning. I hope everybody is awake. Good. So, first of all, thank you so much for having us here and giving Eutelsat this opportunity to interact with the young minds sitting right in front of me. And it is such a pleasure to see everyone. And while this is more about satellite, more about technical part of satellite, and Dan and I were like, when we entered and we were just thinking like, how we can make a small value addition to these students who are aiming to do something big in their career, in their lives, through this particular life of space. So while Dan would be more about tech part of it, and he's all there for you to ask any number of questions, and I'm talking on your behalf, Dan. I would like to present what we do as a Eutelsat and what is this whole new thing about space communication and how it is changing the lives of the humanity. And I'll just quickly run through a few slides, which I'm assuming you will like it. So, of course, Eutelsat Group, we are one of the only group in the world which has its own 35 odd geo satellites and the constellation of Leo. By simply understand, you are all space students, I'm assuming. So geo is, of course, at the 36,000 odd kilometers. So you just get one satellite which covers one particular part of an area. And when you come to the Leo satellite, which is right at an altitude of just 1200 kilometer, 400 to 1200 kilometer. So you need more number of satellites. So hence it becomes a constellation, just a law of physics. So of course we can deep dive about it, how this, and that's where the whole challenge of bringing the communication on Earth becomes important using Leo constellation. And why it is important? Because while we are speaking, we are the privileged class, mind you. There is 3 billion people still do not have high speed or any, connectivity on the earth still. So we are those privileged class who have all the facilities of the world, but there are still the areas, there is still the black holes, where the connectivity is yet to reach. And there comes the satellite communication part of it. This is all our, the entire satellite architecture and everything. It is how we are covering the globe. So we are basically connecting everywhere, anywhere on Earth, in air, of course, the ocean. So what this whole constellation and the satellite does is provides you the connectivity wherever, whenever you want. And hence, space communication is one of the most important field of science or tech or connectivity in today's time. Uh, I'm not going into these things. For that, I let Dan speak about what is the difference, why we use Geo and Leo. A small example I have already given. It's more about massifying the connectivity through Leo constellation. This is a small example of, or the first one then, keep me honest here. This is our first gateway. This is called gateway, this is how the communication, the satellites talk to our gateway on the earth, basically, right? So you have satellites in the space, and then something is required on the earth to get that traffic back, right? So this is called as gateway, and this is one of the pictures of our original gateway, the Svalbard, which is first one for us, which is helping us bring the connectivity to the earth, on the earth. How do we work? We actually, as a group, we work with all the telcos, all the satellite operators in the world. All the top brands, top logos are associated with us. That's the big ecosystem across the world we have built. So that's how we are bringing the whole ecosystem through our organization. Just a quick one, how do we connect? We connect with the terminals, which are called UTs, user terminal, which get installed at our premises. When we say the office premises, the rooftop, or if it is a ship on the ship, or if it is an aircraft, or if it is an air connectivity. So these are the terminals which are getting used. So I'm giving you these quick, words, the terminologies where you can just correlate and visualize how the connectivity is happening, how the communication is happening. So you have satellites in the space, you have ground infrastructure on the earth, and then you have a terminals at the customers and the premises, which is getting basically a symphony is getting done. And that symphony is what Den does for us. And he has to do a good job because nobody likes to have a latency, high latency in web searching and all. And when you are watching Netflix, you don't want the video to buffer, right? And that's the job of us. Okay, so what it does is it opens a plethora of use cases. Earlier when we were having a geo satellite communication only, so that was not, we were not able to massify, like the word what I use, or we were not able to give you those kind of, because with the geo, just again, because it is a 36,000 kilometer, the latency is around 700 odd millisecond. Now with the LEO, there's latency, and I'm assuming latency everybody understand here, less than 100 odd millisecond. What it does is it just open the real-time applications, and hence it is becoming absolutely important for us to understand this part of the tech, basically, that how we can really use and change the lives. And that's where I said we are changing the humanity, because in the rural area where still small students, 6-year, 7-year-old, walking for a good couple of miles or 4-5 miles in India for the education, we can give that education. Maybe Amity professor sitting right here, connecting in the rural area, giving this good education on LEO constellation connectivity, because latency is less than 100 millisecond. You can have a right video call over there. So that boy or a girl, a small girl, don't have to come to Delhi to study because they can't afford that. But education can go to them. That is the change this technology brings in, apart from, of course, telemedicine and many such use cases. A quick videos, a small video, this will give you, this is what we have
Or
connected.
the
This is a
people in
live
Greenland that are
use case.
living places where we don't have the submarine cable.
So
it
this
could
is
be
a
a way
power
to
plant
ensure
we
that
have
remote
connected.
places of Greenland will be connected to the outside world. This could be a game changer.
One of those hard-to-reach places is Bjørgøksfjord, Greenland's first and largest hydroelectric power plant. Critical infrastructure which powers 15 cities and 60 villages. It can only be reached with a 2-hour boat journey from the nearest city. The power station is situated 600 meters inside a mountain and consists of 14 kilometers of tunnel. Thanks to the partnership between TUSAS and OneWeb, it is now connected.
It's very important for us here in Buksfjord, because we are a remote place, to have some reliable connectivity, especially when we have problems if there's a failure on the transmission line or with the grid in Nuuk. One example is last year we had a long outage of 10 or 15 hours. The means we had were satellite phones. Here they only work for maybe 2 or 3 minutes, then you get disconnected and then you have to wait for a couple of minutes and dial again. It's not just phoning and emailing, but also our equipment. We want to have remote sensing of different things, engines and water supply and different things, and we need a reliable, fast connection for that. This new OneWeb connection is much faster than the old connection we had. We can use technology here same as in our homes.
So you just saw that a small, it's a critical infrastructure. So while I was speaking about, the consumer use case, this is more about, just one hydropower plant, which was not having a connectivity or a high speed connectivity real time. When you have to do monitoring, you need low latency kind of a technology. And that is where the LEO comes into picture. Quickly, I'll also like to present the India thing, what we have done. So you will love to see the kind of work in India we have done. We have all the coverage of, in India. We are very own ISRO. We have used ISRO Launchpad to launch our 72 satellites. So right now we have around 650 odd satellites in the space, and out of 650, 72 have been launched from India with ISRO. So wonderful job done by ISRO, and the quick one, we will just showcase the kind of work. So this particular video is in on the move. So we give connectivity. You can just put that terminal on your vehicle. These are army jawans. It is in the area of Joshimath, which is 7,000 odd feet high, right? There we did this with the army people, and they were just happy because they have never seen such kind of connectivity on the go in those hill terrains. You don't get that, of course, right? So this is what we did. This is how you set up this. This is our terminal. This is all with the Indian Army. We are working very closely with Indian Army, Indian Navy, Indian Air Force, all the three defense forces we are working. You see the kind of connectivity we are providing to them. This is one of the very good use case, or how we have supported Indian Air Force when there was a bird down and they wanted to find out where is that bird. When we say Air Force bird means, you know what I mean. The Anand would be knowing that. So this is where we help them. This connectivity helped them to recover that. And none other than our telecom minister have interacted. These Javans, what you are seeing on the screen, they had never had the chance to communicate to their families because they all are sitting in the border security areas where you don't have even call to make. They have to walk to their base to call their families. Now we are connecting them, giving them, there was a live call done with none other than our very own honorable telecom minister. So this kind of work we are doing. This is unmanned vessel. So I'm just trying to give you how the glimpses of the this connectivity, how it is helping. So there is no, this is which is called as unmanned vessel in the Indian Navy. We are connecting that as well. Operation Brahma, everybody must have already heard about it. We were the first one to give this connectivity so that this medical facility was set up by our own forces, and connectivity was provided by Eutelsat OneWeb, and that's where we made a difference. You know, we were, like I said, in the less than two days, in less than 48 hours, we were up there and connected. Because any such disaster, what happens is the first thing goes down is the connectivity, right? That is where the space communication comes into picture. And we were awarded by our forces for the good work we have done. This is our Indian gateways, just to feel you connected, that how much work we are doing in India. And these are, one is in Gujarat, another is in Tamil Nadu. So these are the two places where we have set up our own gateways. And we are the first LEO operator in the country. We are the only company in this country who can provide LEO connectivity and the enterprise grade, secure, resilient connectivity, what Dan was speaking about. It's not about just providing connectivity. It is all about providing the secure connectivity, because it is all about security of the nation as well. So a lot of things are associated with us in these manners, but this is a small, we wanted to present to you, and we are all here to address your queries. You want to know something more about, we would be very, very happy to do that. Thank you so much. And once again, thank you for giving us this time. Thank you.
Thank you, Nista, for providing very great and extensive information about how the OneWeb satellites are working and what are their transmission frequencies, what are their the spectrum bands, and how the LEO and GEO can all the electronics and communication engineering can understand this word. When we are providing the services through LEO, we are low Earth orbits and the geostationary orbits. So low Earth orbits are up to 2,000 kilometers above the Earth, and the geostationary is more than 35,000 kilometers. So latency varies in that case. The amount of data or the signal is coming, that varies. That is the difference in between. So they are providing the good services, good frequency with minimum latency. That is again is a great thing that we can right now think about and expect about. So thank you very much. And now I'll request Gurinder Singh sir to say a few words, and then we'll open this session for questions. So we understand that the information provided to us can raise a lot of questions among all of you, because they providing the fast internet services, because we are right now working for 5G and 6G. 6G was where we are expecting the lowest latency. What Nista's told about is 100 ms less, but now we are expecting in 6G that is 50, less than 50 ms. So that will be the ideal condition when we are having the minimal amount of latency between the signal is reaching to us through our mobile phones. So please, sir, and then we will open the.
I think that I'm very cautious of the time because 11:30 we have another interaction which is planned there. So we have about 5 minutes. I wanted to give chance to the students to speak more because I'm sure that they are having questions. But very warm welcome to the delegation, Mr. Daniel, Group Captain Andrao, our very own Nishtha Kapoorji, and very bright students we have. I think Amity School of Engineering and Technology, Amity Institute of Geoinformatics, Amity Institute of Space Science, Amity Institute of Aerospace Engineering, Amity Innovation and Design Center. And the more importantly, I think that we need to look at that how your organization and Amity can work together. I think that is very, very important for us, which we like to search on. When Nishtha was talking, I was remembering Kostab, uh, uh, who used to be like you, sitting in a crowd and sitting there asking questions. And Kostab, when she left as a CEO of Airtel, Kostab became the CEO of the Airtel, and he belonged to Amity. So first of all, huge applause for her. Uh, but Mr. Dan, I wanted to tell you that you are addressing one of the brightest lot, and our founder, Dr. Chauhan, who's watching you live, and all vice chancellors who are watching you live, you're on YouTube, uh, that there is a passion in the DNA of MIT students. So all of them, they are very bright. They do a lot of research. And you were talking about the application of the satellites. There are more than 650 satellites today. But I'm talking about 15 years back, that when there were very few satellites, MIT became the largest contributor in the India by practically implementing the project called Pan-African E-Network project, through which we implemented and gave the education to 80,000 African students. So TCIL and TCS, they became our partners, and with the Ministry of External Affairs, we went to the villages, interiors to Africa. I remember I used to go to Africa almost every week, and this was the dream project of Dr. Kalam, who used to be the president of India. But we, as an institution, we really want to contribute, and through the satellite-based applicability, both in tele-education and as well as in telemedicines, we have contributed quite a lot. But we'd like to listen more from the students, and when we are discussing, we'd like to understand that what we can do together. But few areas where we feel that the students and your company can work together is one is internships. So we would like to create some projects where the students can do internships, maybe practically in a company or maybe virtual internships. Would like to understand what are the topics on which the students they can work with you. What are the research topics where we can collaborate and we can work. Second is the apprenticeships program. So maybe that at Amity, Dr. Chauhan has always propagated that doing is something in which we believe. So we like to understand from you that can we create some apprenticeship projects with you where the students can practically work. I'm also very cautious that there are a large number of research scholars who are sitting here. So we can create some projects for them. I think that one of the major points you touched on was the connectivity of the terminals, which are very, very expensive. By the way, more than 40% of the companies, I was just try to Google it, they went for the bankruptcy, who are in the telecommunication areas. So we need to see that how we can reduce the cost of connectivity, especially in the terminals, so students can pick up some research topic, and maybe that we can involve engineering students, telecommunication students, and business students together, that how we can reduce the cost and how we can make and we can become more relevant to the companies and to the ecosystems. Also, we like to understand from you that can we create some programs with you maybe certifications, which can be good for the students, but a lot of things to discuss. But let me give it to the students. But such a privilege to welcome you on behalf of our founder, Dr. Chauhan. And again, thanks to the delegation who have come. We have a lot of respect. And I think that we started up this education system through Amity Institute of Telecommunication 15 years back. And then we offered this as a specialization. Good to see and explore that what we can do together. Thank you so very much.
Thank you, sir. Thank you, sir. Now, the session is open for questions from all the professors in the front row and the students. If you have question in your mind. Just raise hand, yes, please. Yeah, one by one. Right?
Good morning, sir.
Yeah, it is working. Go ahead.
Good morning, sir. I'm Dhruvi Shah. I'm a final year student in Masters in Space Science and Technology. So I'll first tell you about my work. So I have worked in the orbital designing of low Earth orbit mega constellation and also internal, external and debris collision avoidance system using quantum and AI. And the collision avoidance system is fully autonomous and onboard on the satellite. And what I want to ask from you is that what are your thoughts or your company's thoughts on making collision avoidance system completely autonomous and on board so that the satellites can communicate within themselves and can decide the maneuver?
That's a very good question. So is this working? Okay, it's working. Yeah, so that's a very good question. So in 2015, when we started the design of our constellation, one of the things that we were investigating very closely is complete onboard automation. And we eventually decided not to do that. Now, we have an automated system today that's automated with the ground in the loop, with people in the loop. And the reason why we've chosen to do that is because we want to ensure that there's sufficient communication about what the plan is. Because in our minds, at least today, it's very difficult to get all of the awareness and all of the information onto the spacecraft in a timely manner for it to make the decision. So if we look at future generations of the technology, look at future generations of satellites where there's almost constant connectivity to the spacecraft, then perhaps that can be done. But just making the decision on the spacecraft itself without then broadcasting that information everywhere else isn't in our minds a good idea, because that decision needs to be communicated, because it could affect other people and it could affect other satellites that may not be broadcasting their location, their plans. So it's a question of intent and communicating your intent properly. And then it's also a question of the cost of the resources. So the compute resources on a spacecraft are significantly more expensive than compute resources on the ground. And so there's a trade-off there about, what the processing power you're using on the spacecraft is versus, and the cost of doing that versus what's on the ground.
So, sir, when you said that other satellites won't be broadcasting, so for that also, in my work, what I did was that I already gave my model the locations and the real-time information of the satellites orbit, the already present satellites, so that the satellite constellation satellites, whenever they are maneuvering, they do not collide with the satellites in the orbit or or each other or the debris. And so one more thing, when we are designing the orbit of say 100 satellites or 1,000 satellites, so do we include AI in that? Because I created a model that used graph neural networks for creating or for synthesis of orbit between 20 to 10,000 satellites in one go as a mega constellation. So
Sorry, I think I missed the question. What was the
Daniel.
question on the end?
I will send you the report of this.
No, it sounds interesting to look at.
See it in my department. We are trying to create a small AI engine which can decide the maneuver of the satellite using a standard wheelchair and all those formulae, plus the probably debris.
Mhm.
That's the one part.
Yeah.
I will send you the report. Give me time.
Okay, no, that sounds good. That's good.
Okay.
Thank you. That was
Thank
interesting to hear about. Thank you.
She is the PhD aspirant, so that's why she's giving you the problem.
The challenge of providing the information to the satellite, or is providing sufficient information to the satellite, right? And one of the problems with space is that not everyone shares where they are. Uh, Governments in particular are very reluctant to tell you where their satellites are, and so that's where it becomes a bit of a challenge to do not closing the loop with other operators, right? So what we do today is, we evaluate the situation. We use third parties that tell us where collisions could occur, and then we make plans to avoid those satellites. But then we take that plan and we send that plan to the U.S. government. We send it to some private entities as well, and they have to take those plans and compare them with what other people are doing in secret, right? And then they come back and they say yes or no, right? And it's not always a clear thing where we can get the answer. So even though we could compute it on the spacecraft, right? But we would still have to close the loop with the ground to do it. So it's a question of where the optimization point is in the space for where you make the decision. But the one thing I've learned is in space, we're always dealing with technology in orbit that's 5 or 10 or 15 years behind in terms of capability. So what we have on the ground, the compute power that we have on the ground, is many, many, many orders of magnitude beyond what we have in space. And so I have worked in the past on something that was similar to what you did, and it was a very simplified model. And I know things have improving and things are continuously improving. So I think it will get there, but so it's interesting to hear about.
Let's give a big clap to our, what's your name?
Thank you, Ida.
Julie. Let's give a big clap to her. Brilliant question.
Next
Now-
one. Yes. Uda.
You please interact with him later on, even after lunch, and it's good. We'll have another 10 minutes.
Hello.
Yes, please.
Good morning, everyone. My name is Utkarsh. I'm a student of Amity University, Uttar Pradesh. So I have a question for
What
Mr.
institution?
Dan.
Which institution?
Amity University, Uttar Pradesh, Noida. ECE. I'm from BTech ECE. So I have a question for Mr. Daniel and Ms. Nishita, that Eutelsat and OneWeb has recently partnered with themselves. So what are your future plans, that how you're going to enhance yourself for the upcoming youth? And secondly, will Eutelsat compete with Starlink globally? That's my question.
So it's difficult for us to comment on future plans because we're a publicly listed company, so we can't really reveal what we're planning to do broadly. So, and especially me. There's a lot of information on our website about some of the projects that we're working on in the future. But I would say, we're not directly competing with Starlink, right? We are a business to business provider. We are working with distribution partners to enhance the ecosystem, to provide more solutions to end customers through these trusted partners. So we're looking to kind of build up the rest of the industry to help them, go into a new technological area rather than kind of cannibalizing the customer base that currently exists.
Thank you. Thank you so much.
And next here.
Good morning,
Just a
sir.
minute, just a minute.
You want me to add? Okay, no, I think Dan has beautifully captured that. As far as our partnerships are concerned, we are, of course, this is our Gen 1, and we are, as an organization, getting into Gen 2. So, of course, there are a lot of partnerships, global partnerships, and of course, why not India? Because, like I share that India has helped us launch 72 satellites, So, we would be partnering with India as and when business is getting synergized for both the parties. And Starlink, very well answered by Dan, that we don't compete with them. They are a different consumer-based, provider, wherein they will directly come to your home, we do not go to home directly. We are basically a secured enterprise grade connectivity, like I mentioned, and we are more defense and large enterprise organization where companies or defense is looking for the resilient infrastructure that we become that secure layer for the nation security. So that's what we would want to position ourselves. Thank you.
Yes, please. Next, introduce yourself first.
Good morning, ma'am. I'm Aryan Ganesh from Amity Institute of Defense Technology. My question pertains to your presentation in particular, and its technical application. So my question is, India with its rising developments in infrastructure, would infrastructure be a particular challenge in order to get the communication towards cities? Because, we have buildings of different heights varying varying structures, right? So is there a chance that there is external interference that could potentially disturb the communication? Yeah.
Very, very good question, and thank you for asking that. Yeah, so I must say that we should be proud as a country that we are one of the highest connected country in the world as far as the fiber is concerned, of course. So we are generally connected. We don't need to really put our satellite communication in the cities, and that actually addresses the concern what you raised. So because of the height of the one building is different than the other building, we may not need the satellite communication in the cities. Where we need is in the hilly terrains, where we need in the dark spots, where we have enough space to bring this connectivity through space. And if you want to add something then to this.
Well, I think you covered that really well, right? But the one of the reasons why I joined this company, right, was to provide our tagline in the beginning when I joined was access for everyone, right? So the goal for me and for many of the others who are at OneWeb and now Eutelsat was to provide connectivity into the dark places, into the places where there's no fiber for hundreds of kilometers, where it's not feasible to bring that fiber in and to provide connectivity solutions at the level for a village or for a business in an environment, right? And so that's what we see as really our solution space there, rather than in the cities.
Specifically for the defense, see, you know what? As a defense, what is happening in the world right now, right? We say we are living in the VUCA world, right? Not so VUCA because everything is seen that we are destroying by our own hands. Okay, so highest budget allocation throughout the globe every government has done is in the defense in last, if you say 6 months. Actually, I'm not even talking about a year, I'm taking 6 months. If you go back and see some reports, the highest budget allocation of the governments are happening in the defense. Why? Because the first thing what they have to do is secure their country, secure the borders. And there comes the satellite connectivity. And there comes this layering of the communication. So you can't only have the redundancy built with the fiber only or a microwave only. So you have to have a true redundancy. When you say a true redundancy, it's not an alternate path of a fiber, it's actually alternate path of a different technology which comes as a space technology. So that's where we come in. Yeah, thank you.
Good morning, sir. I am Syed Wajid Ali, a student of Amity Institute of Space Science and Technology. Sir, I did my major project on SAR data compression technique. For that, I built an autoencoder to compress the SAR raw SLC data from 32-bit to 2.32-bit by preserving the important matrices like SQNR, phase error, and coherence. And for that, I also got first place Young Researcher and best poster presentation in 7th International Conference on Recent Trends in Materials and Devices, that is ICR TMD 2026. Sir, my question is, ULET's LEO network is great for latency, but SAR data is huge. Are you looking at integrating Edge AI into your terminals to compress that data before it hits the satellite?
So I think one of the great things about digital communication networks is that you can put all kinds of applications in front of the connection, right? The connection that we provide is just digital. So I think if there's a user that has a high need for something like that, that needs a solution for compressing data, and there's some novel approaches that can be used to compress that data, that those users would probably be very interested in seeing those kind of solutions in front of them.
So that's the last question because of the paucity of time. And then we will consider your other questions. We can consider offline in the E2 lounge. Yes, please.
Good morning, sir. Good morning, ma'am. It's my privilege to have you all here. Thank you so much for taking out your time. Before I point out two questions, I would like to share the work which I'm doing. I'm Sudhin Manish from AISST, Amity Institute of Space Science and Technology. According to the Eutelsat's website, which I saw, you're working on satellite communication and networking, and I'm working on the major project related to that. Basically, I'm working on LEO constellation satellites, and my major objective in my major project is to minimize the overlap because, as you know, there are many satellites. So each satellite cannot look at the same thing at the same time, because of which the power wastage will happen and everything. So minimizing overlap and also maximizing the coverage is what I'm working on. And I've done it using 4 different algorithms. One is the MILP, mixed integer linear programming, and AI methods, classical heuristic method, and the meta heuristic method. And also I use quantum. Then I found out the limitations of it and merged quantum with taboo search method and built a model on that. Thanks to our faculties for helping me for that. And I would like to ask you 2 different questions. Number 1, in Eutelsat's multi-orbit architecture combining GEO and LEO systems, how are scheduling and resource allocation handled across different orbits? And is there any scope for optimization based approaches like the one I explored in my project? Number 1. And number 2, the question is, does Eutelsat use centralized or distributed scheduling strategies for constellation management? And how is Eutelsat working with this?
Thank you for those questions. Those are very good questions. Let me answer the second question first, perhaps. So I would say that we use a centralized planning method, because I think, as you were looking at with your research, when you're trying to optimize allocation, you have to do it in a centralized place. Just solving the problem in a distributed way, you can solve parts of it in a distributed way, which is what we do, right? We solve the problem part in parallel, and then we solve in the end to do the final optimization. The challenge, though, around optimization is that optimization doesn't always give you the best long-term answer. So if you optimize for coverage, right, to use the fewest number of satellites in coverage, you're correct. You aren't wasting power. Let's say you aren't wasting resources, but what you are losing is a bit of robustness, right? So when you have a sparsely populated constellation with minimal overlap, you have exactly that, minimal overlap, which is good from a capital investment perspective. But the problem is, in space, things age, satellites decay, and then you're left in a spot where if you have one satellite that goes out, now you have a hole. Whereas if you have a overpopulated mesh, there's some redundancy in place. So a user terminal can look at the sky. Maybe it has to look a little bit to the left, a little bit to the right, up or down, whichever way it is, to go see another satellite. So in the end, you have to kind of balance those two together. So when you're doing your initial launch, I think it's good to have a very optimized approach for laying everything out. But then when you're looking at 5 years, 10 years down the road, when there's some decay to the satellites, when components start breaking, when they can't perform at the optimal, because when you launch the satellite, that's the best it's ever going to work. It's never going to work better than that. Then you need to, as you fill in the constellation, you need to kind of provide redundancy, which then adds resiliency. So when you have, a problem, whether it's a little oopsie where the satellite goes out of service for 4 hours, or it's a longer problem that takes several days or weeks to recover, the user experience doesn't suffer because the system is so optimized that there's no solution that it can find.
Thanks. We will take one more.
This one last one.
Yes.
Hello, sir. Hello, ma'am. Thank you for having this session with us. So, as we are at the end of this session, and already we have discussed about the AI, we have this AI in our hearts from like now years, right? So, a business type of question, like a very small type of question. So, I've been reading some articles nowadays we are using Claude Code, just by putting a prompt, we are getting such big lines of code without bugs and everything. So, my question is like, how it is affecting your business, is it in a good way it is affecting, and in the future when this AI technology is it is elevating like very fast, so are you like thinking like it will be like at the advantage, it will be your advantage or like
So I would say it's definitely helping a lot. The capabilities like Claude Code, right, are really helping, particularly my employees, do their jobs more efficiently. I've hired a lot of aerospace students to be our satellite operations team first line. Depending on the program that they went to, they don't necessarily have strong development capabilities, but they have ideas about how we can do operations better. And tools like this, like Cloud Code as an example, really provide them a new tool that they can use to transform their ideas into prototypes that work. And then of course we integrate them with our software development teams so that they can kind of refine those prototypes into robust code that we can use in our operations. Because the challenge is always, in the end, when you're running something that's a space application, you have $1 million thing on the other end of the line, and if you make a critical error on it, you can break something that costs millions of dollars, right? So there's a balance between moving fast and then and reliability that we have to come in, that has to come into play. So we like to use those tools for prototyping, I would say. And I've seen some great stuff that my young engineers have done along those lines. And then there's kind of a cycle of refinement that we go through in order to make sure that it's suitable for using for space applications. But thank you for the question.
Thank you very much. So let's have yeah.
Just 1 minute. See, first of all, brilliant questions. Let's clap for our students. You are the best. You asked so wonderful questions. I was amazed to see the depth of knowledge in this area. So he is going to be here till about 2:30, 3 o'clock. So please also find time to interact with him also, because so many hands were raised and then we didn't give all opportunity. But certainly you can communicate with them through us, and you coordinate with Shefali. If you want to even send some questions, small questions, we can send it on WhatsApp and to them and get the reply. So thank you. You are brilliant. And also, I would request Mr. Anantarao, Wing Command, our group captain, to say a few words. He is the one who brought this opportunity. May I request Group Captain Anantarao, the director of ISPA. Let's give a big clap to him. It's not in the program. So thank you so much for bringing him, the delegation here. Thank you.
Thank you very much, Founder President, Sir, Dr. Gurinder Singh, Dr. Selvamurthy, and Dr. Pandey, of course, Dr. Shefali also, for agreeing to bring this delegation here. And we also thank Dan and Nishta for agreeing to visit Amity University. It's been a great experience as always, and we look forward to more interactions. As far as space is concerned, you all know that space technology is developing very fast. What is the technology today may not be relevant in a few years, so we need to keep updated always with what is happening across the world, especially in the space technology matters. And for this, we need to have two things. One is collaborations, and collaborations means between universities, between the academia, the government, the industry, the PSUs. We need to have collaborations, and in that also Amity is doing a good job. And the second thing is skill development, and skill development is one area where Amity is doing a great job. And you all must be aware that what is required today is industry ready workforce, and therefore you need to be updated with whatever is happening, and these kind of sessions do help in bringing about this kind of readiness levels. So once again, I thank all the dignitaries here present on stage, and we wish to have more interactions of such nature. Thank you very much.
So with this,
I think that there is a very special message from your beloved founder president. He's saying that he was very impressed by the question which students have asked. So first of all, a huge applause for all the students. So I was noting down the kind of questions you were asking, but you will, all of you who have asked questions, you will get a special appreciation in terms of a book and a special appreciation letter from our founder. So give a huge applause to your founder also, who was watching you live. But all of you who have asked questions and those who are present, we're really impressed by the kind of questions you have asked, the kind of intellectual inputs you have given. Thank you so very much.
thank you. Thank you, sir. And let's have a huge round of applause for everybody now. And thank you for being a great audience this morning. And you had really raised the great questions in front of Mr. Daniel and Ms. Nista. And thank you very much. At the outset, I would like to thank our Honorable Founder President, sir, for providing such type of ecosystem where we all are interacting and sharing the ideas, the thoughts, and knowledge among each other. Thank you, Founder, sir. And thank you, Mr. Daniel, Mr. Nista, and Dr. Salamati, sir, Dr. Gurinder Singh ji, and thank you, all of you. And let's meet for next session in the lounge. Thank you very much.
Engineered. Good afternoon, distinguished dignitaries and our esteemed guest. This powerful thought perfectly captures the essence of today's deliberation. Space science today is no longer confined to exploration alone. It has become an integral pillar of global development, driving communication, connectivity, security, and sustainability. From enabling real time communication across continents to supporting disaster management, navigation, and digital incursion, the space communication industries stand at the core of modern civilization. Thank you so much, respected Vice Chancellor Ma'am, for joining the deliberation. In today's rapid evolving landscape, the role of academia becomes more critical. Universities are not only just center of learning, they are incubators of ideas, innovation, and future ready talent. When academic excellence converges with industry expertise, it creates an ecosystem where knowledge is translated into impactful solutions. Guided by the visionary leadership of our Honorable Founder President, Sir Dr. Ashok K. Chauhan, Amity University has embarked on an ambitious and forward looking journey in the domain of space sciences. His vision for the Amity space mission is rooted in empowering young minds to actively contribute to India's growing space ecosystem by fostering cutting edge research, encouraging innovation, and building indigenous capabilities in emerging science and technologies. Today's session is a reflection of that very synergy, bringing bright minds together, bringing bright and aspiring minds together with global leaders from the space communications sector. It is an opportunity to understand how cutting edge satellite technology, advanced communication network, and the visionary leaderships are shaping the future of our concerned world. We are indeed privileged to host our distinguished representative for Eutelsat Group and Eutelsat OneWeb and ISPA that are redefining the future of global connectivity and advancing the frontier of space communication. It is my honor to invite Professor Dr. Sunil Khatri, Additional Pro Vice Chancellor and Dean Academics, to deliver the welcome address for the session.
Thank you, Dr. Isha. Mr. Daniel, the Vice President from Satellite Operations, Eutelsat Group, accompanying Ms. Nishita, Group Captain T.H. Anand Rao ji, Director of ISPA. We welcome you to the campus for this very important discussions. I hope that your interactions with the student in the morning are wonderful, and definitely we are going to have some visit of our facilities after this discussions. I, on behalf of our Honorable Founder President, Dr. Shri Ashok Chauhan ji, our Honorable Chancellor, Dr. Atul Chauhan ji, our trustees, Shri Amol Chauhan ji, Shri Abhay Chauhan ji, welcome you to the campus. We have a very great coincidence with you. This is for the outcome driven values, for something which is in perfection, you believe, and that is what Amity is also all about. Our Honorable Founder President was in Germany for 28 years, acquiring 6 industries, 6,000 Germans working under him. But then he decided to come back to India, to the cause of the nation, to the cause of the society, to the cause of education. And with this objective, this vision, this mission, he had started this Amity Education Group, which has been now in India 12 universities, all independent state universities, at 18 campuses globally that we have. Many of them are independent degree awarding capacity institutions also. But today's discussion, today's day is very important for Amity because our Honorable Founder President, who had set up this Amity Space mission, which is very close to his heart, and discussions that we are going to have today with you are going to set a direction for us, expectations that what we can do together in research, in academic activities, in training activities together to learn from you. Under this Amity Space mission, with the visionary leadership of our Honorable Founder President, University is working in a mission mode to position ourselves as a national leader across the space, science, and technology, including research, innovation, technology development, and industry integrated solutions, which we think are aligning with your objectives also. Your organization is going to spend 50 years as establishment next year, I think 2027, you're 49 years old. And we are also emerging very aggressively in the area that we want to set up as one of the best global university. All our practices that we have here in academics are aligned with international standards and benchmarks. Even in academics, if you see whatever the University Grant Commission, which defines and regulates the higher education in India, or the new education policy 2020, whatever they are thinking, they're thinking it way ahead. For example, they talk about now global collaboration in terms of joint degrees. We have been working with our group vice chancellor, Dr. Gurinder Singh ji, has been working in this direction. For last 20 years, we are seeing that our students should collaborate and have the joint degree programs, twinning program, credit exchange. In academics, with our Honorable Vice Chancellor, Dr. Balvinder Shukla ma'am, you will see that whatever the best practice is, whether it is in terms of defining the graduate attributes, learning outcomes at the program level, and even at the course level, establishing the competency metrics, how aligning with them, how we can have the comprehensive exams to assess that what the students are expected to learn or achieving or not. And definitely, because of all this, we have been accredited, only university in Asia to be accredited both by QAA at UK and WESC from US. So this has been a privilege with us, some unique recognitions. We are the university best ranked in terms of Times ranking, in terms of employability. So we are also setting new standards, new benchmarks, and for us the new expectations. As our Honorable Founder President always says, that nothing is short that can be believed, and we have to do something which is impossible for others to do. Today is your visit. We are looking forward very excitingly to do something very interestingly jointly with you. And I would like to thank Group Captain Raoji, who had helped us with this visit. He had been visiting now second time, and thank you, sir, for having this visit arranged. And I do believe that with Miss Nishta, who have been, in this region, looking forward to, with your presence, with your coordination, definitely we will do something greatly between these two wonderful organizations. Thank you, and once again, welcome to this university.
Thank you so much, sir, for setting the tone of the discussion. Eutelsat Group is one of the world's leading satellite operator, providing secure and reliable connectivity solution across the globe. With a strong presence in both geostationary and low Earth orbit satellite system, the group plays a critical role in enabling broadband access, broadcasting services, and data connectivity in even the most remote regions. Through its integration with Eutelsat OneWeb, Eutelsat is one of the forefront of next generation satellite communications, delivering high speed, low latency connectivity and bridging the global digital divide. We now look forward to gain insights into one of the world's leading satellite operators. May I now request Mr. Daniel, Vice President Satellite Operations at Eutelsat Group, to share his remarks.
Maybe that's the best. Yeah, that's the best. Hmm? Yeah. Yeah, yeah. So thank you very much for having us here today. I really appreciate the invitation to come and speak and talk to you a bit about kind of the intersection between industry and education. For me, as I was saying downstairs and interacting with the students, what we're engaged in with LEO constellations, with low Earth orbit satellites, is a change in how the space industry works. It's a different approach to doing business. It's a different approach to operations. It's a different approach to engineering. We're taking a different mindset towards risk. We're taking a different mindset towards delivery of service. And one of the major things that I think we've learned in the process, and I think it's something that's kind of been a little bit of a surprise to us. I don't know how here in India we talk about the quality of mission, right? But in the United States and in Europe, we kind of talk about Class D, Class C, Class B, Class A, where Class A is the top of the top. And what's interesting is that with a LEO constellation, what we're trying to provide is kind of Class A service with a Class D spacecraft. And people often ask us, our manufacturer asks us, how can we possibly meet these requirements for doing doing high performance systems with such a inexpensive spacecraft, such a potentially failure prone spacecraft. So a spacecraft that individually doesn't have enormous reliability, enormous availability. And the answer is, it's a different way of thinking about it, because you're solving the problem with volume, not with precision. You're solving it in a way that allows an overlap between the different satellites that are serving. And even though you end up in a situation where, let's say, a single satellite has an issue, you still have 600 other satellites that are performing the mission in parallel. So that's a little bit about what I kind of wanted to share. And now I have the slides, and hopefully I can okay, there we go. Perfect. So yes, I just wanted to share a little bit about where we are technically, and how what we do is different from maybe some of the ways that space engineering and space operations have been done in the past. So I shared a little bit about myself downstairs, but this is me. I'm the vice president of satellite operations for Eutelsat. So that means I'm in charge of both our LEO operations, our OneWeb operations, and our geo satellite operations. So I kind of see both worlds. I see the new startup mentality of the OneWeb side, and I also see the heritage geo operations, where we provide 99.999, as many nines as we try to calculate level of performance and reliability to our customers. And it's different mindsets, and we're looking at how we bridge that divide. So where did I come from? As someone mentioned, I have a degree in computer engineering. Originally, I was not in aerospace, but I came into aerospace. I love space. Space is really cool. When I was a kid, I wanted to be an astronaut. I think probably like many of your students did as well. But I studied computer engineering. I got into software projects. I got into systems engineering, and that led me into space. Because in many ways, satellite systems are some of the most complex systems engineering problems that we have. Satellites are very difficult systems engineering problems to solve. After doing that for about 9 years, I joined a startup, and the goal of the startup was to build a satellite in 2 years, a high-performance satellite in 2 years. We did that. Somebody asked me, hey, do you want to do this? And being a very naive 30-year-old, I said, how hard could it be to make a satellite work? And I poured a lot of blood, sweat, and tears into that project, but we made it work as a team. And when we launched, and it was a very successful satellite. And that's what brought me into satellite operations. After I programmed the code for making the satellite work, I then had to train other people how to use it and then fly it alongside them. And I discovered that I had a real passion for kind of the firefighting side of space operations. And then a few years later, I moved to OneWeb, and the reason I went to OneWeb is because we had partnered with the French on with Airbus on how to build our satellites, but we wanted to make sure that we knew how to operate them. So I went and embedded with the engineering team there as we did the design of the spacecraft, so I could bring back the lessons around how the spacecraft actually worked to the operations team, so that we could fly those satellites. We launched the first 6 satellites. Then we launched another 68, I want to say it was. And then because of COVID, we went bankrupt, and we shrunk the team from being 120 people flying 70 something satellites down to 20 people. That's all we had. And so we had to learn how to innovate. We had to learn how to cut out the steps that we didn't need in order to be a optimized engineering team, and then scale ourselves up to flying the 600 satellites that we're flying today. I think we talked a little bit about Eutelsat. There's different numbers of geo satellites. It depends how many we're counting. If we're counting just the ones that we're operating, if the ones that we're selling capacity on. But sometimes we say 34, sometimes we say different numbers, but it's in the 30s. We have 654 LEO spacecraft in orbit. You can see those are the red dots. They're spread into 12 planes. We don't need to go into the geometry of the constellation, but we can always talk about it. Right now, about 130 people work for me across 4 control centers. So I have a team in Mexico, a team in Paris, a team in London, a team in Washington, and we all work together to fly these spacecraft. But for the LEO constellation, some of the information that I wanted to share is about the scale, because I think what we don't think about often in space is we often think about doing one thing at a time. We think about one spacecraft and our interactions with one spacecraft. And when you go into a constellation setting, there's a lot of things that change about it. So if you talk about years on orbit, so we have 650 satellites. That's a year and 3/4 of time elapsed every single day on those spacecraft. So if you think about the design of a spacecraft, if there's a condition that can occur, once every satellite year, you would expect to see it happening one time on a satellite in space. It will definitely happen once or twice or 3 times during a day. So even though it's a low probability of event, in the context of a constellation, it becomes a high probability event. So your system has to be robust enough to handle those sort of things. We run 10,000 contacts a day. I have 2 or 3 people that are working at any time that are monitoring the entire fleet. They're not paying attention to what's going on. The system has to be there. The automation has to be there to respond to it. We execute 50,000 procedures. 2.3% of them fail. So I should have done the math and put that on the slide because it's hard to do math in real time. But that's something like 4,000? No, that can't be right. 400 procedures fail per day, right? So that 400 things break all the time. So normally when we think about space, we think about how do we achieve as close to perfection as we can. When you have a constellation, you're not going to see perfection. You could grind and grind and grind away, but there's always going to be that edge of the curve that it's going to be almost impossible to climb up from an effort standpoint. So you have to tolerate failure, and that's a different mindset in a lot of cases. It's a different mindset than we have on GEO. GEO, it's everything has to work all of the time, and we design the system like that. On LEO, we have to sort of take a step back and say, okay, we know that things are going to fail. How do we make sure that they fail in a safe way that it doesn't impact everything? We process, so what does that translate to? That translates to 64 days of compute runtime every day. So if you look across all the computers that we're running on the ground, we're running 64 days worth of applications every single day. So the great thing about that is you get a lot of exposure. Anything that you do is happening repeatedly during the day. And so as a result, you quickly find all the little corner cases. We process 500 billion telemetry packets. It's an enormous amount of data that's flowing through the system. And that was one of the challenges that I mentioned earlier, is that, we really need to find new innovative ways of sifting through all that data, looking for failure trends that are emerging before they show up. One of your students asked a very good question about conjunctions. We handle 27,000 conjunctions messages a day that we have to adjudicate, that we have to decide whether we're going to act on or not. Of those 27,000, we act on about 3 of them. So it's an enormous amount of processing that we have to do on what's going on in the constellation to maintain situational awareness and then take action on that. And then if we look at how many commands we're executing on the spacecraft, it's something like 50,000 on the spacecraft per day. So 40,000 of those are used to control the service. And then we have some automation on the spacecraft that runs to sort out errors. That's about 2,000 of the commands. And then the rest is sort of orchestration and groundwork that we do. I don't need to rehash the history of everything that we've done, but we started this in 2015. We're now 11 years later, really in the heart of the program. We've had some bumps along the way, but it's been a continuous track of evolution and improvement. And for us, the important thing is that we had to be ready to do operations for the first satellites that launched. And that was long before we went into commercial service. The rest of the company, the rest of the team had many years to perfect what they were doing before commercial service started. But we had to be ready in 2019 for those first satellites with a system that could support that. And then we could alter it under the hood and continuously upgrade it as time went on, which requires just kind of a different way of looking at things. I've kind of touched on a lot of this as I've been going through, but just to hit a couple of highlights. So what's important from a ground systems perspective as you're doing this is a flexible architecture that allows you to swap things in and out. It's important to have an open systems approach. You can purchase software from commercial services at the beginning, but often what we found is that the requirements that we have for a constellation are just different. And it requires smart people that are able to do development on their own to solve the solutions as they encounter them. Because the challenges that we find are very hard to write requirements for. It's very hard to guess what's going to happen. And so as a result, we have to do our own development. Scaling infrastructure is really important. It's really hard to manage a data center, is what we've learned. We're a space company, not a data center management company. So we've gone to cloud providers as an alternative so that we could do that. But in the end, we've built this highly automated system. We have, if we're talking about a non-change period, so during the day when everybody's working, yes, it takes a few more people to be there because people have to input the change. We have to make sure the changes are working properly. But at night when nothing's happening, we have a mission director that's somebody who sits around and kind of adjudicates problems. And we have one engineer that's sitting there controlling the fleet, and that's it. The satellites are flying themselves, or really the ground system is flying the satellites, and the operators are sitting there with the ground system, interacting with it, controlling it. And when the errors happen, they're dealing with the errors. And what do? We deliver something like 99.95% availability from the satellite perspective. That doesn't translate into the customer availability because there's a lot of other factors that come into play. But what's important about that is that's 4 hours per satellite per year. But the recovery time for a spacecraft that a human is involved in takes something like 12 hours. So we can't have the satellites fail and always have to have people in the loop to bring them back. We have to set up the satellites, we have to set up the ground system to handle it on its own, to do it autonomously. I don't think I need to go through this level of detail with you all, but really the point is that all the satellites are slightly different, but the automation allows us to control them in the same kind of fashion. So that gives us the ability to have repeatable execution of activities and make sure that the people are really just focusing on the exceptions, not on the gross execution of the problem. I don't think there's anything really important to touch on here. Just kind of going through our overall setup that we have. I think the important thing that maybe to highlight is that we have a microservice architecture, and that's really important to allow us to sort of substitute pieces of the system in parts. If you build a giant monolithic system, it becomes very difficult to have upgrades, and so we try to build everything with very small microservices that allow us to move forward. And then this is a slide that I like to describe as the hierarchy of pain. So when you're operating a system and you're selling service to customers, there's acceptable problems and there's unacceptable problems. I mentioned that a single satellite, has an impact, but generally from the customer's perspective, it's kind of tolerable. What they can't tolerate is if the whole system goes down. Absolutely not. But even beyond that, if just one plane goes out, that also causes a lot of problems. So we've had to develop a scheme for performing our testing and our validation to avoid creating problems that cascade across the whole constellation. We have a number of means to do that. I was talking with someone just before this about digital twins, and we kind of have that in our space vehicle simulator. But the challenge is it's basically its own satellite, and so it requires just as much effort to fly that space vehicle simulator as it does to fly a satellite in a lot of ways. But it's great for doing validation. We have FlatSat, which is a hardware, complete hardware setup of our satellites that allows us to validate at a very low level everything that we're doing. And then we're also using our non-service satellites. So I said we launched 650 in orbit. With 650 in orbit, we're only using about 600 of those for service. So that gives us 50 to kind of use as a test fleet to check things out. And so this is how we generally avoid problems on the fleet. This is how we test things. We test in the development environment. We use our digital twin, our space vehicle simulator to make sure things work. We test it against hardware, and then we test, in gradual steps. We roll things out to the constellation as a whole, and that really is what gives us our ability to kind of constrain our failure space and allow us to build something that's highly reliable out of, we'll say, Class D components. So that was really what I wanted to share with you in terms of what we're doing from a space operations perspective, and communicate a bit around how we do mission operations and the changes in philosophy that you have to take. And so really, it's about automation, flexibility, having something that's adaptive both from people and from a systems perspective, and then also a culture that embraces, we'll call it controlled failure. We don't want to open up and just let failure happen without controls in place, but we want to set it up so that when things do fail, we're able to contain the failure, respond to the failure, and then improve the system. So.
Thank you, Mr. Daniel. So before we proceed further, there is a small message from Honorable Chancellor, sir. Mr. Daniel and Ms. Nista, all present over here. Honorable Chancellor has conveyed that he is watching all the sessions since morning and participated in all the sessions till now, and he is very keen and waiting for the further sessions all day, and he has sent his greetings to Mr. Daniel and Ms. Nista. It's his vision that the Amity University is right now is the top and the leading university in the research and innovation worldwide, and the large number of faculty and student innovations that is coming out of the university every year. It's more than 5,000 3,000 patents has been published till now, and more than 15,000 publications are coming every year, and approximately 170 as index, and that is because of the ecosystem that is provided by Honorable Chancellor Sir, Honorable Founder Sir, and time to time they are providing us, they're making us interested with many of the missions, and the latest is about the the quantum mission which Solamurthy sir has just mentioned about, and the mission AI. And thank you, sir. Thank you, Chancellor sir. Thank you, Founder sir. Thank you for your.
Yeah, thank you so much, Group Captain T.H. Anant Rao, sir, for interesting confidence on Amity University and bringing this distinguished delegation to us. And Dr. Daniel mentioned in the morning that this is your first visit to Amity. So I hope we have made our standards and
The first visit to India, it seems.
yes, yes, first visit to India, sir. And I really feel fortunate that I have been chosen by the Honorable Founder President to coordinate the various activities under Amity Space Mission. And lot many activities have already been conducted. And we have also prepared a short video, which will be we will be screening. And you will be seeing highlights of the Amity Space activities we have done till now. And I'm so grateful that delegation is here, and we are really looking forward to have the collaboration with you, and we are looking forward. Thank you so much.
Shefali, before you show the film,
So,
Manoj mentioned about the Chancellor. I thought of saying a few words about our Chancellor for the visiting delegation. Dr. Atul Chauhan is the President of the Foundation now, and also Chancellor of Amity University, Uttar Pradesh, and a few more universities. And he is also President of our Foundation, which gives the complete coverage for the whole Amity Education Group. He is a product of London School of Economics and also University College of London for both economic management degree and engineering degree. So he has a combination of both engineering and management. And then he has early part of his studies have been in Europe, in Germany and Europe. So he is now spearheading all this activity, research, innovation, under the able guidance of our founder president, Dr. Ashok Chauhan. And for him, research and innovation is the forerunner. So the curriculum design, pedagogy, the method of delivery, the ranking and accreditation, everything depends on research and innovation as the highest priority. And he has launched the Amity Quantum mission, which is also linked to space. We are now looking at quantum communication, quantum security, quantum key distributions for safe communication, secured communication. So he is our chancellor, about whom Dr. Manoj Kumar Pandey mentioned. Thank you, Manoj.
Over the last decade, under the visionary leadership of Dr. Ashok K. Chauhan, Founder-President, Amity Education Group of Universities and Institutions, has made path-breaking research and academic achievements in the field of space science and technology. Driven by the vision of Founder-President and Chancellors Dr. Atul Chauhan and Dr. Aseem Chauhan led the research and development endeavors in space science and technology, significantly contributing to India's space mission. Amity's advanced research infrastructure includes Amity Institute of Space Science and Technology, Amity Institute of Aerospace Engineering, Amity Institute of Geoinformatics and Remote Sensing, Amity Center of Excellence in Astrobiology. The Center for Ionosphere Studies was created with support from ISRO to study the equatorial ionization anomaly QUEST. The Amity Center for Artificial Intelligence, in addition to Amity School of Engineering and Technology, provides high-speed processing for machine learning, deep learning, and data science, supporting space data and analytics. These institutions, while churning out skilled and competent workforce in space sector, are focused on research and innovation. Under the guidance of Dr. Aseem Chauhan, Amity University has launched its first biological payload from India into space by ISRO through PSLV C-60 SpaceX mission from Satish Dhawan Space Center. This experiment from Amity is an effort to study space-grown food, which can be helpful in future for manned mission and Bharatiya Antariksha Station.
I'm happy to share that it has been a successful downlink from the satellites with the data coming in.
AI-based ship detection using optical imagery strengthens maritime security and surveillance, while SAR image processing identifies unlit dark vessels. They also contribute to space situational awareness through satellite debris conjunction prediction and tracking. The Mars Analog Station in Ladakh tests extremophiles in Mars-like light conditions. The Earth and Space Exploration Program in Leh Ladakh to simulate Martian environment and understand human behavior in such challenging environment. Amity University has expanded internationally advancing space research, and at Amity University, Dubai, Dr. Atul Chauhan has established a satellite ground station, enabling students to receive valuable data from satellite, particularly with the objective to predict climate conditions and support UAE's Environment Vision 2030. Under the visionary leadership of Dr. Mrs. Amita Chauhan, Chairperson Amity International Schools secured first place at NASA's prestigious International Space Settlement Design Competition, showcasing their excellence and innovation at the global stage consecutively for the last 5 years. AMIO, the preparatory schools led by Mrs. Sapna Chauhan, is kindling and igniting the passion for space science even among the toddlers. Strengthening its commitment to space research, Amity University signed an MOU with RRSC North in March 2025 in the august presence of Dr. V. Narayana, ISRO chairman, who also glorified Amity's contributions to scientific excellence and expressed confidence in a long and impactful collaboration. It is also a moment of pride as Amity University's AI-powered Cyclone Vision gets integrated with ISRO's technology and celebrated by Honorable Prime Minister Shri Narendra Modi ji.
हैकेथॉन में जो सिस्टम डेवलप किया गया उसे अब इसरो द्वारा डेवलप की गई टेक्नोलॉजी के साथ इंटीग्रेट किया गया है.
Amity University has undertaken various initiatives in partnership with ISRO through numerous impactful engagements. Amity University Bengaluru hosted ISRO Amity Joint Workshop highlighting critical themes including artificial intelligence, data analytics and astrobiology. Amity University Noida hosted InSpace, Amity Joint Workshop for students, researchers and industry stakeholders for promoting entrepreneurship among young aspirants and a joint short-term skill development course on essentials of space technology in agriculture sector. During the past years, Amity University has been recognized by the Indian Space Association as academic excellence in space education and research for its unparalleled contributions in the space technology sector. We are proud to be among the top 100 institutions from India selected to participate in the ISRO-led research discussions at IIST Thiruvananthapuram. With the support of national space agencies and under the guidance of Honorable Minister of Science and Technology, Dr. Jitendra Singh, as well as ISRO Chairman Dr. V. Narayanan, Amity is steadily advancing its journey toward research excellence, contributing meaningfully to the vision of Honorable Prime Minister Shri Narendra Modi ji.
The founder president of the Amity Group, Professor Ashok Chauhan, who is not only a pioneering academician in his own right, but has carried the tradition of Indian education across the globe.
As we continue to explore the vast frontiers of space, science and technology, Honorable Founder President has launched the Amity Space Mission, under which we are committed towards innovation, collaboration and excellence, and emerging as a major contributor to India's space aspirations.
I feel obliged to me that, as Dr. Salwamurthy told, the most important partner in your public-private partnership mission, and we will leave no stone unturned.
I would like to mention that this video not only captures our journey so far, but also the large vision of empowering students and researchers to innovate, explore, and lead the ever evolving domain of space sciences. Now, Professor Dr. Balvinder Shukla, respected Vice Chancellor Madam, is a distinguished and a visionary leader. She has been instrumental in strengthening Amity's commitment to excellence in education, research, and global engagement. Her leadership continues to inspire innovation, interdisciplinary learning, and the pursuit of knowledge aligned with the national and global priorities. It is my privilege to request Ma'am for her valuable remarks.
Most respected Honorable Founder President, sir, Honorable Chancellor, a very distinguished guest today, Mr. Daniel Krobot, the Vice President of Satellite Operations, Eutelsat Group, Ms. Nishtha Kapoor, Regional Director of India, SAARC and Africa, Eutelsat OneWeb, and our very dear friend, Group Captain T.H. Anand Rao, Director of ISPA. First of all, I would like to extend a very warm welcome to Mr. Daniel Krobot and Ms. Nista at Amity University. I was getting the feedback about the morning's session by you for our students who were highly excited and have asked a lot of questions to you. And at Amity, we always try to give the exposure to the student interaction with the industry leaders and global leaders like you to give their exposure and to broaden their horizons in the emerging technology areas and other emerging areas. And so we are really very thrilled that you have interacted with our faculty and the students in the morning and sharing your expertise and experiences with them from the aerospace and especially the satellite industry. I'm certain that the insight which you have shared have been very valuable for the student and it will help them to pursue the excellence in their respective field of study. Our Honorable Founder President Dr. Ashok Chauhan, so vision for Amity is to deeply rooted in innovation and global leadership, having himself spent more than 3 decades in Europe before coming back to India for the nation building. Our Honorable Founder President believes in empowering students to become change makers and thought leaders equipped to address the complex challenges of our time. And your visit at this moment aligns perfectly with this vision of Honorable Founder President as we strive to foster a culture of innovation, research, and collaborations. And our commitment to the cutting edge, as you have seen a video on in the space area. That way, we have the various disciplines where our faculty has been working in the cutting edge areas and bringing the innovation. So we have more than 3,000 patents which are filed by our researchers, the scientists, and nearly 500 patents are granted and over 500 plus collaborative funded projects by our researchers and scientists in diverse fields are there. Our group vice chancellor is sitting here that he has been right from the when the even the internationalization was not that concept. Our founder president brought the concept, and since 1990 he has been working and across the globe visiting the various universities and industries to partner with the Amity University with the objective to bring take Amity to the world and bring word to Amity. And that's what the philosophy our honorable founder president he's propagating and giving the exposure to the students best of the education system and at the same time giving the global exposures. Our accomplished, Dr. Silvamurthy is going to make the presentation shortly. How the Amity has really built that ecosystem of research and innovation and bringing the best of the brains from across the globe at the Amity University. And we really take a lot of pride in our accomplishments in the field of aerospace and space science. Dr. Professor M.S. Prasad, our great scientist, Professor Sanjay Singh, our Professor of Aerospace Engineering, and when you will be visit our various labs, and you will find that industry-led techno teaching and the research labs we have established at the Amity University. Recently, the Amity students represented India at NASA BTL Phase 2 and being the declared international winner in Level 1. A student at Amity School won the top prize in the International Space Settlement Design Competition, where they designed a lunar settlement that eclipsed global rivals, as well as that Amity has also fostered the vibrant startup ecosystem through initiatives like Project Dividrishti. Our Dr. Shivani is sitting here, and whose research projects was selected by the defense services, and nurturing the entrepreneurship, positioning our nation at the hub for innovation ideas and cutting edge technologies. And that's what the vision is of our Honorable Founder President, how we contribute to the nation building as well as to contribute to the Viksit Bharat 2047. And also how to contribute to the world, to make the world a better place to live. And that's where our Honorable Chancellor said how we can bring the synergies with the various organizations while we collaborate. So it's not only serves the purpose and objective of Amity University, but it's how it serves the purposes, objective of the two organizations who come together. And bigger than that is how that serves the objective of the world and the countries. So it's very, very important. And your visit today at Amity University is extremely important. And I'm sure that Amity University and USTEL will be working on areas which are the mutually interest, and we can further the technologies ahead, which is the for the benefit of the society and the communities and the world at large. I would like to highlight also that in line with the industry demand for the cross disciplinary graduates, and that our honorable chancellor has taken a very visionary step that always that Amity University is a very student centric university, that how we provide the best of the education, best of the option to the student to build their career from the university. And for last 2 days, the Amity team has been working on the briefing the students on the boundless, where the boundless is concept where the student has unlimited choices to choose their minor or to choose their second discipline at the graduation. So the Dr. Khatri, our additional provisor, was sitting here because we had the briefing of the students. This is the fifth group we are doing the briefing, informing them that what all the options they have while they choose the career options, whether that they want to go and start their own venture, or they want to join back the family business, or to go for the higher education, or go for the corporate career, or to for competitive examinations. So what all electives they have got in the form of minor or in the form of the second majors. So the student can build their own degree and can also develop their pathway, the direction in which direction they want to go after graduating from the Amity University. Amity being the student-centric university. So that's why Dr. Khatri has gone to do that briefing. And I'm sure that your visit today will undoubtedly open the doors for potential collaborations and partnerships, driving innovation in satellite technology and space research. We are grateful for your time and expertise, and that you have. It's your first visit, and I would not say it's the last visit, but it will start the series of visits and the discussions and the collaboration, the lasting synergetic relationship. We look forward, therefore, to exploring the opportunity for the joint research initiatives, internship or mentorship programs that will shape the next generation of students, one side, as well as the way the scientists and the researcher working in collaboration with your research. And your presentation was really impressive, that how you are able to build that flexibility and provide the service which the industry needs. Thank you so very much, and very warm welcome at Amity University.
Thank you so much, ma'am, for your valuable remarks and presenting the visionary approach of the senior leadership and how it is inherited in the Amity's ecosystem to support students and researchers. Moving ahead, we have Dr. W. Selvamurthy with us. He is a distinguished scientist and a visionary leader. He has played a pivotal role in shaping innovation-driven ecosystem and advancing strategic scientific initiatives in the country. His guidance continues to strengthen Amity's commitment towards cutting edge research and national missions. It is now my honor to invite Dr. W. Selvamurthy, sir, for his valuable remarks and highlights on Amity's space mission.
So, good afternoon, friends. Let me first of all express our gratitude to Group Captain T.H. Anantarao, Director of ISPA. He is the one who has brought this distinguished delegation. And he has served in Indian Air Force for more than 3.5 decades, and out of which he has flown fighter aircrafts like Jaguar and the MiG series, and then he served in Air Headquarters as well as in the Air Command Headquarters. So such a distinguished person has taken over the helm of the affairs in the very important organization ISPA, Indian Space Association, and he has kept Amity in his heart. You know, once they looked at for an academic partner, he said, "Why don't you go to Amity?" That is the distinguished university. So thank you so much for Anandarao for bringing this delegation over here. And Amity, as founder president, has put the significance on Amity space mission, that he wants Amity to be the best partner with ISPA. As you may have many academic institutions, industries, but then we would like to be a major contributor. So you want this as your resource. So we will do a lot of activities with ISPA, and through ISPA, connecting with distinguished delegations, industries, as well as institutions. As was mentioned, Dr. Ashok Chauhan has created this whole Amity education group we call Amity Universe, just to create the future global citizens. The philosophy, education philosophy, both Dan and Ishna, that the philosophy is to churn out the future global citizens who are endowed with knowledge, including spiritual knowledge, skills including soft skills, good behavior, sanskars, values, resilience to face challenges. This is what is our philosophy. We are not giving degrees alone. We are creating the future global citizens. Then the other important component is we are research and innovation driven. So the whole curriculum design, pedagogy, method of delivery is to promote creativity, innovation, problem solving ability. This is what we give to our children through our educational system. That is the USP of our Amity Education Group. So in this, you are coming at the opportune time, the most opportune time, when India is looking at becoming a leadership role in space science and technology. One, to be among the leaders in space science and technology. And ISRO and the government of India is now developing the national capability. So Amity would like to play a significant role. That is why founder President Dr. Chauhan has announced Amity Space Mission, in which you saw in the video that all that activity which is happening both in academics, research, and innovation. So we like to become a partner with you. I like to mention about Eutelsat, Eutelsat. See, he mentioned about 600 plus and in the LEO, and then 34 in GEO. And but above this, 7,000 television stations, 7,000 across the globe, and in 50 countries, more than 50 countries. He is the customers for this Eutelsat is having that number, and also 1,400 high definition television connections, and also direct to home DTH. So these are the services which are being provided. With all this constellation of satellites, he has already spelled out what his vision is for in satellites. How do you build more satellites? And also, how do you predict the life of the satellite? How do we enhance the life of the satellite? And also, how do we make it more intelligent to avoid collision and also create more debris? So, how do we give that intelligence to the system? Can we also do a predictive maintenance of the satellites? Can we also look at prediction of its survivability and then improve the shelf life by intervening? So these are the challenges, particularly students sitting there and also faculties. So he has spelled out some challenges which you can look at. Then you are getting so many data coming from the existing satellite. You have a lot of experience. How long it lasted? What are the problems encountered in the satellites? How do you now look at synthesize this into a knowledge base? Thereby, you will be able to create new model, data analytics, artificial intelligence. Today, Amity has established 10 petaflop computing capability today. We'll take you to that facility. We are upgrading to 60 petaflop. And so our students are exposed to AI in all sectors, including space science. Then the other important thing is we have all that systems institution required. We have Amity Institute of Space Science and Technology. We have Amity Institute of Aerospace Engineering. We have Amity School of Engineering and Technology, where more than 7,000 students are there in this campus alone. And then we have also Amity Institute of Defense Technology, where aerospace engineering is one of the vertical which we have built in defense technology. We have Amity Institute of Nuclear Science and Technology, because one of the payload which Professor Prasad is looking at to monitor the radiation, monitor the atmospheric pollution in the 3 CubeSat which he is building now in Amity Institute. He is building this year, he is planning to launch it into the space. So this is where we have Amity Institute of Nuclear Science and Technology, where US Department of Defense has invested $1.2 million here to establish the nuclear security facility. So we work with US Department of Defense. And so this is Amity. So we build partnership. So 3 missions Dr. Ashok Chauhan has created, operational missions. The one mission is Mission Connect. So we would like to connect with ISPA, we would like to connect with the Eutelsat, and we would like to connect with our Indian partner. So Mission Connect. Mission Synergy. We would like to add value to your activities and endeavors. So by contributing, Mission Synergy. And you will bring synergy to Amity endeavors. Then the next thing is mission outcome. We work on outcome based, tangible outcome to be in the partnership. So if you sign an MOU with you, which we are planning to, then we will also look at what is the outcome from this. What can be delivered to your mission? So this is outcome, mission outcome. Then we also created 4 technology mission. The first mission is Amity Space Mission, which Honorable Founder President Dr. Chauhan announced. Amity Space Mission. Amity Green Hydrogen Mission. So we have a very strong Amity Green Hydrogen Mission, which is to be powered. We are even looking at satellite to be powered or spacecraft to be powered by hydrogen, even though we use hydrogen, liquid hydrogen as a fuel. So can we look at hydrogen fueling this our satellites? Then we have Amity Institute of Quantum Mission, which is our Honorable Chancellor has launched. Now the 4th mission is Amity Semiconductor Mission, because these are the critical missions for the country. So Amity is working on such critical frontier areas of research and development, and we'll be very glad to partner with you. You have seen the videos. I am not going to repeat what all has been said. Only thing I want to mention that Amity Institute of Space Science and Technology, they will be speaking during the deliberations. I would request Professor Prasad, Shivani, and also Aerospace Engineering to highlight what they are doing. 2 important things I will mention about this. One is data science. We have signed with, you saw in the video, National Remote Sensing Center, where we are looking at the data. That is why we signed the MOU with them, and also we work very closely with all the regional remote sensing centers, which is available across the country, 15 of them. So we have signed in presence of Chairman ISRO and Chairman, both the former one and the present one, they have signed agreement. And Somnath ji was in our campus in Bangalore, Amity, Bangalore. And then also Narayanan, we signed an agreement. You saw that in the video. So we have a very strong mission looking at the data. So because we have a data science group as well and AI, so we have handled this. So this is one area perhaps you can look at as a research collaboration for this. Then we also have ground station. So all your satellites, 650 satellites, can we get data from there? Because we have in Amity, Dubai, we have established a ground station, you saw that. So our students are looking at how do you convert this data, information into a knowledge. So maybe that we can feed this for your satellite building, predicting the life as well as its probability to fail. All that we can look at as a prediction models we can develop using the LLM, and also the Amity, the space science and technology can work. The other area is thermal management. We have a very strong group in asset where we are working with laser group. Laser sources create tremendous temperature. So we are doing a dual pump cooling system, which is a very novel method for cooling. So we are working with DRDO, where I served for 40 years, and out of which 10 years as Director General. So we are working there. Another one which Prasad is doing on the submarine welding integrity, which could be also used in spacecraft or wherever there is welding. They are doing it for the submarines. But we can do that. How do you do the welding and look at the integrity of the welding? Can it be welded properly? So they are doing the AI model for this. So what I want to say is just to show that we can work on this. Then another one last point is that we are also looking at data transmission when the satellite data comes to ground station, stratosphere as well as troposphere. If there is magnetic, electromagnetic disturbances, how will it affect the data transmission and distortions? So this is Amity University, Chhattisgarh is working in this area. So we have created a research cluster, not just only this campus, but we have experts in various campuses of Amity Group. So we are connecting them through a research cluster. So they interact very periodically, they interact, and then they build the group competence rather than just one university. So we have created like this some thematic 15 clusters. One of them very important is space cluster. So these are the things I thought I will tell you, and we will work with you, and we like to build a very strong partnership. Amity, we can give intellectual capital. We can give brilliant students to come there for internship, to be placed there for jobs, and use Amity as your resource. And we'll show you some of the labs which are relevant, like design. We have a very strong design center. We have a very strong artificial intelligence center. So some of them we will be seeing after lunch. So welcome once again, and thank you, Nishita, as well as Dan. We like to work with you. Thank you so much.
We now open the floor for an interactive discussion session. I request Dr. W. Selvamurthy, sir, to take the deliberations.
So we have brilliant faculties relevant to the delegation we have brought. I will start with Professor M.S. Prasad, who has served in the Defense Research and Development Organization for almost 35 years, and he has worked on strategic program, and he is now heading here. Last 12 years, he has more than 12 years he has been in Amity, and he is now heading the Amity Institute of Space Science and Technology, and he has met you and other people in the delegations in the various exhibitions. So we are fortunate to have privilege to have such distinguished people. So can you start, Prasad? Just.
Good afternoon, everybody. It's all right? Yeah. It's fine. I can talk standing here. Daniel knows me. First thing I would like to say that it was recollecting about 25 years, 30 years back memory when I saw Daniel. Most of you have seen only the PPT, but some of you have not noticed that one man can bring one web to an area where we have 658 some constellation moving around. Till now, they have not, conjectured with the debris till today. And I was telling one of my students that we have 50,000 transactions on the conjunction. My institute primarily is doing on satellite image processing, and we design the satellites. And in fact, we are working with ISRO on complex trajectory analysis. So as I mentioned to you during one of the introductory parts, that what we find is the quantum mechanics computing can be used for our faster computations, because we are taking a lot of supercomputing time. So I'm coming out and I will send you a couple of my works on this, that how to do the space situation awareness using quantum assisted computing, trajectory analysis using quantum computing. I will be shortly sending you the reply. These are the couple of things we are working. Then one of the problems today is that how to monitor the health of an astronaut, uh, not by putting a lot of sensors as the NASA does. Can we do it with couple of sensors and which is more proactive, and we can get the data down below? So one of my colleagues, Dr. Shivani Verma, as I introduced you, is working on this. Thank you so much.
Thank you. Sanjay, he is heading the Amity Institute of Aerospace Engineering.
Good afternoon, sir. I am Dr. Sanjay Singh, heading Amity Institute of Aerospace Engineering. So we are running 4 programs in aerospace, starting from UG to PhD level. And we have around 180 students, aerospace students at present. So our faculty members are involved in different areas, research areas. So we are very good in modeling and simulation. And second is trajectory determination of the satellite communication, and parameter estimation from the data, satellite data. We can estimate based on that. We can
keep it closer.
We can predict this trajectory of the satellite. Structural analysis, we are very good, and stability analysis. We are also doing stability analysis of the launch vehicle, and we have expertise in rocket propulsion. This is very, very important for launch vehicle. So we are very good in rocket propulsion. So these are the areas related to satellite and satellite communications and launch vehicles. Apart from this, related to aerospace aircraft, we are doing research in the field of aircraft materials, natural fibers, structure, aerodynamics, using various like FEM, finite element method, and computational fluid dynamics for stress analysis and for structural analysis, for aerodynamic properties, to find aerodynamic properties using the software's computational fluid dynamics. So we are looking forward to collaborate with you.
Thank you,
for
Sanjay.
these areas.
We'll
Thank
give
you.
it to Ashish Mani. He is in the Amity School of Engineering and Technology.
Thank you very much, sir. I have been working on hyperspectral image processing, and one of the the snippets that you saw in the video regarding cyclone prediction was done by my team. Further, I'm also into quantum computing and AI based system design. So, like we were discussing previously also regarding digital twin for satellites. So we can work on those areas.
I would
Thank
like you to mention about quantum key distribution, where you are working with DRDO. Just mention about secured communication.
Okay. So recently we are doing a joint project with DRDO JCB on quantum key distribution in open space. So far it has been established for fiber optic communication channel. We are simulating it for open space communication, which can actually be used even in satellite communications.
That's why it's relevant to this secured communication. Just
one more point. One of my student, Akshay Khanna. Akshay Khanna, he is associated with OneWeb for the last 5 years. He had joined OneWeb in 2021.
Oh.
Actually, you know, Akshay, he is my student.
Oh, great. Let's give a big clap to Amity Institute of Aerospace.
Hey, Akshay, that we have been to. You told him? Oh, lovely.
So he is my student.
Oh, lovely.
So we are proud to have Amity students in one web. Very good. We'll give you more students. He's a star. Over to you.
Thank you, sir.
We have such people there in Amity. We will give more students.
A very good afternoon to all of you. I am Professor Sunny Kumar Dubey from the Department of Electronics and Communication Engineering. My research area is computer vision and image processing, and recently we are working on some project related with the robotics, and that project is basically a kind of transformation. It's a transformation from robot to the robot to drone, and then drone to then further float. So that's a kind of trimorph, right? So it has a very useful use cases thereafter. So we are working on to that one, and we are looking forward. And as sir mentioned that the challenges, we are very much interested to understand the challenges you are facing, because that will create a kind of scope for the student. So we will love to hear from you that what are the challenges you are facing and what are the loopholes where we can work.
Thank
So
you.
that would be the
Thank you so much. So can you give the mic to J.K. Rai? And
Good afternoon, sir. And I'm Dr. J.K. Rai, Head of Department of Electronics and Communication Engineering, which is part of Amity School of Engineering and Technology. So we offer a BTech Electronics and Communication program for the students and MTech Embedded System Technology program. I'm talking of the programs which are relevant to your field only. Personally, I work in the field of robotics and control theory, but the department offers a specialization in the field of semiconductors, artificial intelligence and machine learning, embedded systems, and communication, which includes satellite communication and navigation also. So we look forward to any opportunity for joint work at whatever, and the opportunity is provided to the students. Thank you, sir.
I would like you people to think about, he has put already some challenges. Look at their endeavors and then formulate what is the new solution which you can give, innovative ideas. So then we will communicate with them. Good. Maya?
Good afternoon, sir. Good afternoon, everyone. I'm Dr. Maya Kumari, Associate Professor at Amity Institute of Geoinformatics and Remote Sensing. So actually, we are the end users. The products which we are getting from satellites, we are analyzing it. At Amity Institute of Geoinformatics and Remote Sensing, we are having undergraduate, postgraduate courses of geoinformatics. We are also having PhD programs. At AIGRS, we are having faculty having expertise in digital image processing, hyperspectral image processing, radar image processing, and even application of geospatial technology in different fields like disaster management, urban planning. And we look forward for further collaboration, sir. Thank you.
And also she is looking at that forest fire, crop health monitoring, in all those data analytics, Maya Kumari and the geoinformatics and remote sensing, and also the landslide prone areas using the remote sensing images. Good, great. Shivani?
Very good afternoon to all. Thank you for coming here. It's an honor getting a chance to interact with you. And it was a beautiful presentation. Our students normally work on these kinds of problems. Actually, we have number of areas which are common where we can collaborate because it is Space Science Institute. And we actually could understand what are the true challenges that a system could face through your presentation, sir. So in our institute, under guidance of Prasad sir, we work on number of problems in space domain. We are collaborating with ISRO. We have developed a new algorithm for tracking of space debris. That is a major problem in space systems. We are also working on CubeSats. Amity would be launching its 3U CubeSat, like Silvamurthy sir mentioned. We are also working on swarm of CubeSat. That is one of the problems of our PhD student. She actually had a query. She would be putting her query before you, sir, so that you could guide her on one of the aspect. We are also working on image analysis, be it any kind of image, optical, SAR, hyperspectral, LiDAR image, or be it fusion of these images to increase the certainty of result. We have worked on it. Mission data analysis, we have worked on Chandrayaan 2, Chandrayaan 3, Aditya L1. So our students keep working on such kind of data. On-orbit maintenance and refueling, that is one of very important problems being faced in space system. So our students have come up with an intelligent pose estimation system where a target and a chaser, they can align themselves and then we can go for docking and maintenance and repair can be taken. We also work in collaboration with defense organization. We are, like sir mentioned, Prasad sir is working on artificial weld defect inspection. We have also developed a unique identification system for humans. So that is a glimpse of work that is done in our department. So may I request Soumya, she had a query, if you can, if you have time.
Just give the mic to her. Isha? You just introduce yourself and put up your question.
Good afternoon, sir. Good afternoon, everyone. My name is Soumya Divedi, and I am a PhD scholar in space science and technology under the guidance of Dr. Shivani Verma, ma'am. And my research work focuses on intelligent path planning of a swarm of CubeSats using decentralized algorithms, and we are kind of trying to maintain the inter-satellite communication links also. So for my research work, I'm exploring various techniques related to heuristic optimization and reinforcement algorithms, so that we can enable the decision making for the CubeSats under the conditions, certain conditions like if there is any link failure or the orbital dynamics. So since there is a lot of information available related to satellite communication on the internet, but we have very limited access to it. So since you are a major player in broadcasting the internet access to the whole world, to the global community, and my question to you is related to communication link in the satellites. So I would like to ask some insights related to communication, inter-satellite communication in these dynamic swarm, and when we are communicating in the dynamic swarm, when the satellites are communicating, and how can we maintain the reliable communication between them when there is a chances of link failures, and link disruption is also there, and these satellites are constantly moving, so in the relative orbits. So how can we maintain that reliable communication between these satellites?
Dan, would you like to respond, please?
Sure. Is this on? Excellent. Yeah, so that's a very excellent question. It's actually very timely too, because as we're looking at the future of our constellation, the future of what we're doing, incorporating intersatellite links is one of the goals. And your question is very good, because that is the question I too have, which is how do we properly manage all of those conditions? One of the challenges that I think we face a lot of times in system design is we often design for the blue sky scenario, the everything works scenario, and we focus a lot of our energy on demonstrating that the system works when everything is working, and how we plug it together. But what we don't spend a lot of time on is how does the system establish itself? How do you, whether it's a constellation or it's a swarm of CubeSats, how do you bring those links online in the first place? How do you establish those first connections? What's the necessary information to feed each of those satellites, the relative motion, the relative attitude, their relative position, so that they can establish those links in the first place? They can build the network in an optimal way. Do you have to have people plan it, or can you develop some algorithms that can come up with some solutions to establish that network? And then you, of course, have the maintenance problem of how does the network self-heal? How do you detect that a node has failed? How do you detect what the cause of the failure is? Because the resolution path may be different. If it's the link has temporarily failed because the attitude of the satellite was upset, that will have some set of observables. If it was the component suffered an upset, that will have a different set of observables. So if the satellite is gone, then it had 4 links around, then at the system level, you'll get some information that says 4 links have gone out simultaneously with 1 satellite. Is that a coincidence that we had 4 adjacent satellites all fail simultaneously, or was it the satellite in the center that failed? And these are the problems that have to be sorted out with the algorithm. So for me, with the research that you're looking at is quite exciting. Yes. Because it's solving, I think, what a real problem is in telecommunications in the near future.
Very good. Let's give a big clap to her. Wonderful question. See, I have already on your behalf requested Nishta and also Dan whether they can be a co-supervisor for your PhD thesis. So I have whispered into her ears.
Yeah, why not? Means I can see the talent and the interest in all the students, and it would be our pleasure if we can do some kind of mentorship, right, Dan? And of course, the Dan has to do that more because he comes from that part of the business. So yeah, so I'm sure we can do that.
Very good. So let's give a big clap to Nishta and Dan for agreeing immediately. Now, I would request Group Captain Anantarao to say a few words, and then I would also request Nishta and Dan to respond. Finally, the concluding remarks by Group Vice Chancellor. So, Anantarao, please. He is the Director ISPA. Let's give a big clap to him, and he is the one who brought this delegation.
Thank you very much, sir, for giving us this interactive platform. I'm sure it will be very useful. I'll just take a minute to talk about what ISPA is doing. While our main focus remains on enabling the industry and policy advocacy towards creating a fruitful space ecosystem, one of the important pillars of ISPA is also outreach. And towards outreach, we have collaborated with many universities and educational institutions. And of course, Amity is the shining example of where space science and technology is being taken forward. And as far as I know, it's the only private university in India which is undertaking space science and technology as a curriculum. So congratulations for that. As far as other educational institutions are concerned, there are some educational startups which are coming up in the country, and we have collaborated with them. We have successfully undertaken space science Olympiads at various schools across the country through a startup called Codimats, and we are willing to do that at Amity also. So I'll request that this Olympiad be undertaken at Amity University, and it's a very useful forum for many of the children over here. We have noted the interest of Amity, and being one of the objectives of ISPA, we will take forward your requirements through our industrial partners. And also, the next point I wanted to cover is about how to make the students industry ready. And I've interacted with a number of companies, startups, as well as MSMEs and other companies. In fact, I do it on a daily basis. And one of the unanimous point that they say is children need to be having real world knowledge, real world exposure, which is something which is missing nowadays. How do we do that? And that's where the industry also comes in. There's a lot of hand holding that needs to be done in the industry. And ISPA is ready to partner in this sphere to make sure that children get some kind of real world exposure through industry interactions. With that, I would only thank the leadership over here for having this interactive forum. Thank you very much.
Thank you, Dr. Rao. Can I request Ms. Kapoor, Nishta?
No, we can. Okay. Once again, and first of all, I would. It's an honor to be here, and thank you everyone, a part of Amity group, to give us this platform. And thank you, Anand, for bringing us here. I can see the kind of, to be honest, let me be very, very honest, I didn't expect this kind of a response personally. And so it's such an overwhelming feeling to see these students and young girls, especially, to see their interest in space. Because, the entire world, we have these averages of diversity in working environment, but then space is the least. We know that, right? And if we have, and as talking about India, and if an Indian girl is going out and making its mark in the space industry, that feels very, very a feeling of a proud indeed. So all the kudos to all the students who are working hard and trying to build their career in this space industry. And we have noted your interest, of course. We would be open to explore how we can support students of Amity group and all the institutes, how we can extend our knowledge of what we do, which can help students to grow in their career. So once again, thank you so much. And it is absolutely pleasure and honor to be here. Thank you.
Thank you, Rishta. Can I request Dan to give the concluding remarks? After that, Group Vice Chancellor, Dr. Balvin, our Gurinder Singh, Professor Gurinder Singh.
Yes, once again, I'll echo what Nish just said. Thank you so much for having us here today. I didn't really expect this kind of welcome either, and it's been very, very informative to see the excitement around space, and also to hear the excellent work that's being done here, the excellent research that's being done here. It's good. And like Nish just said, I think that there's definitely opportunities to explore here. For seeing how we can see if we can find some ways to work together, and to provide some support both ways. It was very interesting also to hear about some of the research that you're doing that wasn't directly related to my area, but is related to the demonstrating the value of space systems for the benefit of mankind, particularly around computer processing of data from spacecrafts, from hyperspectral or other imaging sensors, that we can do things like detect fires and react and monitor crops and all of that. And so one of the things that I wanted to mention, that's something that we're looking at, because I think maybe there's an opportunity here as well, is, as we're launching these next about 600 satellites in the next 3.5 years or so, around 340 of them have the opportunity for hosted payloads. And so I see that you're developing CubeSats, that you're putting some payloads in space. Perhaps there's an opportunity here for some hosted payloads to fly on some of our satellites in the later years. So I think that's something that could be explored along with perhaps the Indian government, if there's something that's of mutual interest there. And Group Captain, you mentioned something around the importance of preparing students for industry. And I tried to talk a little bit about this downstairs with the students, but in many ways, the exposure to industry helps prepare people. Like I think many of the young people that join, because I hire mostly directly out of school in London, they're prepared. They have a very solid education, but there is a little bit of a gap in terms of the practical application of that. And so I think industry partnerships can help bring about that. They can provide that next level of application that brings in the how to describe it, the reality of the situation, the challenges that are faced on a daily basis. Because as we were talking about with forming mesh networks in space, oftentimes it's easy to think about how things operate in the right conditions. It's much harder to think about everything that can go wrong. But the reality is, when you have a system in space, there's things that are failing constantly, and having the mindset around what does failure mean, how do we react to failure, how do we be robust to failure, is something that I think we can improve in the educational process. But it was very interesting to hear all of this from you. Thank you so much.
Thank you, Mr. Daniel. Let's give a big appreciation for Daniel. So now I would request Professor Gurinder Singh, the Group Vice Chancellor, and he has been all through the deliberations. So how he would like to see this collaboration moving forward.
Thank you, Dr. Sulamurthy, who is the number one scientist of India. I will start with your second last slide. I was noting down your points very carefully. I think that one of the things which you focused in your slide, second last slide, which was very prominently focused, was that fail fast. And I noted fail fast. But I'm going to add something of our honorable founder, president, and chancellor, who have been working on the Indian space mission from last many years. That fail fast is fine, but at Amity we say experiment fast. And along with the failure and experimenting fast, try to be then successful fast. So we will complement your theorem with our theorem, that what we have been doing. And we have seen some of our students already working with you. Akshay Khanna, who has been doing a great work, and also Kostab, who has been the CEO of the Airtel. But I think that very important point which you focused was that we need to make the students industry ready. We will be focusing with you. So we would request that if we can create a small working group. Dr. Sulamurthy, our Vice Chancellor, Dr. Shukla also spoke upon the same gaps which we have. So maybe that we will create a small group, and Dr. Shifali, or maybe there's someone whosoever you want to nominate, we can create a group where we can divide ourselves into three priorities: a very short run, then in the short term to medium term, and then in the longer run. But we can create a few initiatives which we'd like to take with your company, including focusing on internships, about which we spoke on. We can also create and send you few research areas where the university has been focusing. And you can look at that. If you feel that you are interested, then maybe we can do joint research. And thank you very much for saying that you will be able to mentor. So I think the mentoring is very, very important, because at this stage, we need to see that the students who are speaking, and we can see large number of research scholars, excellent questions they were asking to you, that if you can mentor them, then they can become success stories like Akshay and Kostab. And then also looking at that, can we create a center of excellence? We already have a space center here, but if can we create a research center here which can focus more on the national interest? As you're very rightly saying, that 650 satellites have been launched in the last 1 year, about 70 from India, and in the next the few years, you're saying that 600 is your target, and 340 if they are from India. Then we can see that how Amity can complement and can contribute more significantly in this area. And also, thank you, Group Captain Andrao. They say that when you meet God, it's very important to thank those who introduce you to the God. So if you are introducing us to the industry, it's very important that we thank someone who has been instrumental. So give a huge applause to him also. So we will be working very closely. We have noted down your suggestion on the Space Olympiad. Our Amity International Schools, by the way, they are creating a history. Only this week, the results were out, and you will find that many of our students, they have got admission into the Ivy Leagues. At Stanford and Wharton, at Harvard, at MIT. So you will find that there are very bright students, but for our school students, maybe that we like to start early. We can create a Space Olympiad, and we'll start working very closely with you. And thank you, Nishtaji, for your continuous guidance and support. We'll create this small working group, and I can see large number of students from Amity School of Engineering, Amity Institute of Informatics and Remote Sensing, Amity Institute of Space Science and Technology, Amity Institute of Aerospace and Engineering, and Amity Innovation and Design Center. We will create a small working group of the students also, along with their faculty. We'll send you a suggestion, and then we will take a feedback, and we'll take it from there for the outcome-based results. Thank you so very much.
Thank you, Professor Greenberg. Now, before we go for lunch, I would request Shafali Kashyap, can you go to the mic and to say a few words, because you have steered the whole organizing this program and steering the Amity space mission over to you.
Election. Thank you so much, everyone. Thank you so much, Mr. Daniel. Thank you so much, Miss Nishtha and Group Captain Anand Rao, sir. And it is a privilege to welcome you. And we have been interacting, and we have discussed lot many things have been emerged. And yes, as mentioned by Dr. Singh, we will create working group, and I will be creating it by today itself. And let's interact more, let's discuss more, let's explore more, because we have various girl child students, as you mentioned, Nishta, that you are interested to help our girl child. And yes, they are doing their PhD, and some are in MSc. And yes, we have few boys also. Please help us. And we have MSc students, PhD scholars, and we'll interact more. Thank you so much. Thank you so much.
Give a big clap to AFSTIA team.
Yes.
Isha Sood, Kamakshi, and Avinash, all those who are here. Very good. You are doing a great job.
I was suggesting maybe, because the student of electronics and communication, maybe aerospace engineering, others, maybe around 18 credits, something, the minor degree as per the AICT, maybe specializing in the discipline can be in the satellite engineering or something can be worked out where the student can do the major project such system engineering. It can be so that the student can do the major project with some courses can be delivered by the organization, some by our faculty. And space engineering. Yes, space engineering is something the minor degree can be worked out. Yeah. Yes, sir.
Very good idea. Let's clap for our Vice Chancellor, who is now, academics. We want to tell the visiting delegation we are number 22 in the country in the NIRF, because I wanted to inform you in national ranking, Amity University is 22. We are just 20 years young. Then in QS and THE, we are on the top private university in the country, which was not told to you earlier, that QS ranking and THE Times Higher Education Group, we are on the top among the, particularly for employability, which you mentioned, employability and international connectivity. We are these two areas, we are in top 100 at the global level. Yeah, we are the best ranking along with IIT Bombay, IIT Delhi, and Indian Institute of Science, Bangalore, and Amity University is the private sector. We are number one. Thank you so much.
Thank you so much, sir. We have now reached a moment where we express our sincere gratitude and appreciation to our esteemed guests. I request respected ma'am, Gurinder Singh sir, and Dr. W. Salvamurthy sir to kindly felicitate our esteemed guest, Mr. Delhi. I request Dr. M.K. Pandey sir also to join in felicitating.
I just want to appreciate Dr. Pandey. In the morning, the whole session of the students was coordinated by Dr. Pandey, and my lot of appreciation to you, Dr. Pandey.
Further, I request the felicitation for Group Captain T.H. Anand Rao sir. I request Ms. Nishta to please come forward for the felicitation. I request each one of you to please come forward for a group photograph. I request all the esteemed faculty members to join for a group photograph.
Can we have the group photo? First, you finish. No, come closer. So, come closer. The 10%. Isha, you can also.
I request all the scholars also to join for a group photograph.
Please. Rachna. Archana. Group captain. Dr. Shukla. Come.
Thank you.
Thanks for all the brilliant students and scholars. Very good. Fantastic.